Hello, everyone. Good morning, good afternoon, good evening, based on the time zone you are connecting today. My name is Victor Monga. This session is presented for Cloud Security Alliance LA chapter. There's a QR code on the screen. You can scan it. It will point you to our social media channels. We have LinkedIn, Twitter, YouTube. Again, this session is recorded, so we will post it on YouTube channel. So in case you want to review it later on, please go ahead and scan this QR code so you can subscribe and stay connected. Let's go to the next slide. So CSA has partnered with another nonprofit organization called Wylie Testing to deliver all of these online trainings, workshops, hands-on. Today we are going to talk about cloud file storage incidents. As we all know, with COVID-19, we all started working from home and we need a shared space in cloud. So a lot of companies, organizations have started using cloud storage, but so are the incidents are growing because bad guys work from home either way. So today we're going to talk about all the incidents happening. Michael is going to walk through demos. We have screenshots. We're going to show you behind the scenes what happens with cloud file storage. All right, let's go to the next slide. So quick about Wylie Testing Foundation, who we are, what we do. We're a nonprofit organization based out of LA. What that means is we are based out of internet. Our focus is to provide online education to nonprofit organizations, conduct and host hands-on experience for our members. And we do also partner with research partners with different organizations, and we participate in their upcoming cutting-edge technologies. We help them test it. All right, let's go to the next one. Today we have Michael Wylie with us. He is our speaker, trainer, workshop guru. So I want to steal the thunder. Michael, why don't you go ahead and introduce yourself?
Thank you very much. I am Michael Wylie. I am the Director of Cybersecurity Services at Richie May Technology Solution. Prior to joining Richie May Technology Solutions, I had a boutique cybersecurity firm here in Los Angeles. We did offensive, defensive security for a lot of different organizations in the financial sector, as well as media entertainment. So now I lead up the Los Angeles office, and mostly these days I focus on the media and entertainment industry. We do pen tests, we do defensive work, incident response, malware analysis, and TPN assessments for studios. I've got a lot of experience in cybersecurity, as I mentioned, both offensive and defensive. I ended up for a while doing a lot of different courses for U.S. Department of Defense. Every year I submit to DEF CON, Black Hat, B-Side, so some of you may have seen some talks or workshops there. And also some of the local universities. I built up the cybersecurity program at Moore Park College, and also at CSUN, I've taught a couple of courses there as well. Move the next slide here. So if you haven't already, go ahead and download what's in GitHub. We want to make sure that you've got two different things. There's a zip file containing evidence. So rather than giving out a VM for these this virtual workshop where I can't go around and help everyone who has issues with VMware or whatever type of networking issues we have, what I decided to do is something a little bit different for this virtual environment. Was I took a virtual machine within VMware, and rather than giving everyone a giant disk that they had to download, what I did is that I had to do a triage image. And so what that is, I took CAPE. It's a free open source tool. Eric Zimmerman wrote it. And I essentially wrote a target which extracted certain things based off of what I wanted for this lab. So in this case, there were certain directories for the different cloud storage solutions that we wanted, as well as some registry keys. So I wrote a target for that. I ended up doing a triage image. It took, rather than a full disk image or a forensic image that might take 4, 8, or 20 hours to do, it was a 10-second imaging process. And so I'll talk a little bit about that towards the end of the slides, but I just wanted to give everyone a heads up. That's a little bit different than normal. There's no VM to download or to extract or to install in VMware Player or VirtualBox. What you're going to get is a zip file. And some people have mentioned that they're having trouble unzipping it with the default Windows Explorer extraction tool. So what you may want to do that's not in the instructions is get 7-zip to extract that. And I just tried that on my one of my new lab VMs, and it worked fine. So if you have 7-zip, you can extract that very quickly. And there's 3 other tools you need to download. If you've got a Mac or Linux machine, you want to follow along and don't want to use these tools, that's fine. But you'll need the tools that are in the intro lab, and I've got those zipped in an S3 bucket for you, but you can also go out to the internet and download that. So you're going to need a registry explorer, which will let you look at some of the registry files I exported. You'll need the DB browser for SQLite, a rich text editor like Notepad++ or Atom, and then a hex editor like HXD or 010. So I give you access to the ones that I'm going to use for the demo and the walkthroughs. And so if you want to get those installed and ready, and make sure you have the evidence-desktop-QS5 or whatever the computer name is, make sure you've got those and just ready. And I'll give you a little bit more time when we do the first lab. But I just wanted to point that out in case people are having questions or not sure if there's a VM for this. I just want to have you rest assured it's just files we're going to take a look at later on, and you need those 4 tools to analyze them. So to get into some of the objectives here for this workshop, what we're going to do is we're going to learn what files are available for examining during an incident. For example, local files, cloud files, deleted files, cache files, and what happens with these different applications. We're going to see what kind of cloud file storage user activity can be audited. Mostly we're going to take a look at free solutions and not a corporate solution, because those you generally have logs and more detailed logs on the enterprise side. And then we're going to be introduced to 2 different scenarios of unauthorized data transfer. We're going to really focus on one of those. And then you'll be introduced where and how different cloud file storage applications log and some of the artifacts left behind. And then learn how to examine incidents with suspected data exfiltration using personal cloud file storage solutions. And so caveat I want to give before we go to the next slide here is that even during building these labs, I kept delaying, and everyone was really great working with me on me missing some of the deadlines here. But even in the lab environment, the applications kept updating and things were changing. So what you're going to see today worked as of yesterday. But if you're watching this as a recording, or you're taking this later and trying to analyze this in the real world, some of these things may be different. A lot of the articles and the research I read and studied for this didn't work when I tried it. So it's a lot of trial and error, and things slightly change. Some things stay pretty persistent. For example, Dropbox encrypts their SQLite databases, and they've been doing it almost the same way since I think 2011. So we're almost at 10 years and they've been doing that similar, but other things are moving, files, storage, that kind of stuff is moving around. So just keep that in mind as you investigate this outside the lab environment. Some credits here. I wasn't able to put everyone's name throughout every single slide and where I read and saw what. Some of this has been the culmination of years of working with some of this stuff. Other things, I grabbed an article or saw a presentation. And so all these people, and maybe there's some I'm missing, have influenced this workshop and some of the information you're going to see. So I definitely want to give them credit for their hard work. So there's many different cloud file storage solutions, right? And I tried to look at just some of the top ones here for this workshop and the talk. There's personal versions, there's enterprise versions, there's different levels of business versions. And so it makes it a little bit of a challenge unless you know which version you're looking at before examining for artifacts. And so I kind of took a look at some of the bigger ones: Box, Google Drive, OneDrive, Dropbox, ShareFile, iCloud, Amazon Drive. And even within those, I started getting a little bit overwhelmed. For example, with Dropbox, there's so many different versions and they do things slightly differently. There's also quite a bit of difference between the free or the personal versions and then the paid versions. And so there's different benefits that organizations can have, as we mentioned at the beginning of this, and why people are starting to use more cloud file storage solutions. They can protect against disasters. So something like a pandemic where you've got tons of data in the corporate office. Well, if you're using something like Box or Dropbox, you don't need to go into the office or do a VPN, that kind of stuff. So it's very convenient and easy. And we're seeing a lot more use of that with COVID-19. There's a little spelling there, but no shared drive maintenance. So you don't have to do antivirus. You don't have to dig into the operating system. You don't have to work on incidents on the file system. There's all kinds of things you have to do with a normal server that you wouldn't have to do with one of these solutions. There's high availability. If you're traveling, if you're in an airplane, if you're on your phone, you have access to these files. And you've got a lot of scalability. You can grow that out without having to add disks or add RAIDs. And then ease of management. So it's pretty much clicky, and you can do permission changes. You can do all kinds of other stuff like that without having to go into share permissions and NTFS permissions and try and troubleshoot DFS and whatever else. So it makes it a lot easier for IT and junior level IT people to manage that. Okay, and so I took this from Spiceworks. I grabbed some of their research that I saw on their website and tried to give an illustration of where we're seeing the cloud file storage solutions and where for if it's small, medium, or large businesses and where you see that. And so as you can see, Microsoft OneDrive is kind of the leader there. And I believe that's because Office 365, you get that part of some of the subscriptions, and it's pre-installed within Windows. And so it's just easy to use instead of having to install a third-party application. Google Drive is second there, and I think that's because G Suite users. And then you've got Dropbox, which competes pretty well with Google Drive, and Box, then it tapers off. I used to see a lot more Box in the enterprise environment. And then Citrix File, I see that a lot in the financial sector, but outside of that, I don't see a ton of uses for that. And we'll, in some of the labs, we'll look at a few of these different examples and we'll walk through them. But once you start getting the hang of how the data is stored in most of these, they're pretty similar across the board. Okay, and then this, again, from Spiceworks, just kind of shows, it's from a survey of 240 IT professionals, and they asked them, well, how do you perceive these different tools and why? And so this kind of gives some insight there. The Citrix share file and Box, it's got pretty low innovation, scalable, ease to set up, user-friendly. These are the opinions of a lot of IT people, and so that's why they're not pushing for that compared to Microsoft OneDrive or Google Drive or Dropbox. They're a little bit higher up on the scale across the board. Okay, and so then the executive problem statement. I know Black Hills Information Security and John Strand kind of does this, and I like that it comes out and says, well, what are we trying to solve for? Why are we spending our Saturday here looking at cloud file storage solutions? So something we do a lot for our clients is crown jewel analysis. And so basically MITRE just defines that as the process for identifying cyber assets that are most critical to a business or the mission of a business. And so we want to take a look at that and say, okay, so if we're moving from a traditional file server that's on-prem and behind our firewall and behind our IDS and IPS and all these other security controls that we have, and we're moving this to a third party, the cloud, is it safe to keep our crown jewels there? Are our security tools working in the cloud? What type of DLP or file exfiltration can we detect? Where are gaps? What existing tools do we have? And then finally, what we're going to take a look at mostly today is what would happen if someone used a non-sanctioned cloud storage solution. So they just installed Dropbox, or they even just went to Dropbox.com, and from there, they were uploading or downloading files on a corporate system. So let's talk a little bit about insider threats. A lot of them. And executives tend to, and I don't want to say executives, but even management, a lot of times we go and we talk to different people, they say, well, we're not so concerned about our people. We did a background check. We got a referral on Bob from someone else in the company. So we pretty much trust them. They've been with us for a certain amount of time and they've been good people. But we're really concerned about the hackers. We're concerned about Russia, North Korea, Iran, China, and those nation states that are attacking companies. But they really just don't take it too serious when we talk about insiders. And so here's some clippings from different news articles talking about some of the major cases that we've seen with insiders. A lot of the little things, you know, data theft or IP theft doesn't get reported, but here's some of the bigger ones. You can see Capital One, NSA, Homeland Security, et cetera, even GE there. Okay, and then there's a report that talks a lot about insiders, Insider Threat Report. Took some stats from the 2020 report that was published recently. And so I thought this was great that they mentioned this. Insiders are our greatest assets, right? And I think that's why a lot of executives are a little bit hesitant on putting controls or investigating insiders. Like, these are our people and we want them to feel good. We're putting in all these culture things and free food and a gym, and now we don't want them to have the appearance that we're micromanaging or we're looking at them or don't trust them. So they are our greatest asset in an organization, but they're also our greatest threat. They've got the keys to the kingdom. 68% of organizations state that insider attacks are becoming more frequent. 63% of organizations think that privileged IT users pose the biggest risk. If we look at the Verizon DBIR reports and Mandiant M Trends, we can see an increase probably since about 2018-19, where insiders contribute to more of the breaches that we're seeing, and not necessarily all on purpose, but they just contribute in some way, possibly a mistake or an accident, or they're taking their work computer home because of COVID-19 and their family members or kid is on a computer and they download something malicious, and that poses a door in for other attackers. 53% believe that detecting insider has become somewhat harder for cloud solutions. And so let's take a look at our case that we're going to look at today. And so the way this is going to work is we're going to have a lab environment of basically that triage image I was talking about earlier of Bob McLee's computer. And so Bob McLee is a senior manager of operations for the Mike Wylie LLC. The company is a boutique real estate investment firm in Los Angeles, and Bob was the senior manager there. Abruptly left yesterday, I guess depending on if you're watching this or not or live, but on 4/17/2020 in the morning. Days prior to Bob leaving, he stepped down from all committee positions. On Friday afternoon, Bob updated his LinkedIn profile to co-owner of a competing real estate investment firm, Remax also. Within hours of Bob's departure, key clients gave contract cancellations. The Mike Wylie LLC management believes Bob may have violated non-compete and non-solicit clauses of his agreement. The Mike Wylie LLC hires forensic and incident response consultants to give evidence of any violations of non-solicit. The company did not have an approved cloud file storage solution, so some users that you know about in the organization are using personal accounts to share files within the company. You reached out to HR, and Bob's personal email address is bob.mclee.re@gmail.com. There is a picture of Bob. Okay, so let's take a look at a couple more of these solutions and differences before we get into our first cloud storage solution, Microsoft OneDrive. So these are the two different scenarios that most often I see when I go in as a consultant. We've got the end users or remote users, and they are behind possibly a firewall or possibly their home's home network, and they have access over the internet to Box, Dropbox, OneDrive, Google Drive, etc. And some organizations have a proxy or a firewall, or they're sending those logs to CASB, which allows them to get more visibility into what the users are doing in these cloud solutions. But these devices like CASBs are generally not in line from what we see. So the scenario we're looking at is more on the right side here, and this is going to be our focus for the workshop. And there may be or may not be, in this case, a corporate issued Dropbox or Google Drive solution. However, there are personal devices. And so our case actually stems from a client that we worked an incident for, and it was an executive, and I've changed some of the details, and it's obviously staged, so we're not giving away any client information, but they had their own solution in the company. But on top of that, there was an executive who downloaded Dropbox, and they installed Dropbox on their work laptop, and they were using that for other things like you'll see in the lab. And so I kind of mimicked that, where there's obviously the corporate owned stuff, but they happen to download these different cloud file storage solutions, and IT security and the investigators don't have access. They don't have the username and password, or I guess we do have the username, we know the email address, but we don't have the password to look into the logs or see what's inside of the cloud solution. And so all we have is that corporate owned machine, and we can start investigating from there. So you've obviously, as I mentioned before, the business on the left-hand side there, you've got it's company issued, you have access to an admin portal, you probably have CASB or detailed logging as far as what you can see, what you can't see, the usability, the activity, the files going in and out, and you can change someone's password and take over their account. But on a personal or free account that a user just happens to use or install on a corporate-owned machine, it's not company issued. You don't have access to the login. There's no central visibility. All you have is access to the endpoint and local logs on that machine, and obviously registry keys. So a couple different examples here. From the incidents that I've looked at, generally when you see non-issued cloud file storage solutions, they are not paid versions. Now, it's absolutely possible that someone signs up for a paid version of Google Drive because they need more storage, and then they use the application or the web browser on a work machine that way. But 95, 99% of the time, we see these free solutions. And so I've given you the current file storage limitations for a free account for each solution. So Google Drive is 15 gigs, OneDrive is 5 gigs, Dropbox is 2 gigs, and then Box is 10 gigs. So that's generally what we're going to see, and that's what you'll see in the lab. So our incident visibility. So what are we going to have access to? So on a personal account, the things that you're going to have access to are the application that's installed. If it is installed, you'll have things, artifacts on the endpoints, like possibly file names, file extensions and types, file sizes, hashes, possibly of a file, path and directories, details about devices that are added, modified, deleted. And the fun part is when we find cached files, you're actually able to carve those out and recover those files. And then users often don't realize the amount of data that's being left behind when they use these solutions. So if it is an intentional insider threat scenario, they may try and delete all the files of the system, but frequently we can recover and carve out those cached files and obviously look at file names, modified dates, and other stuff you'll see in the lab here. Okay, and so this brings us into Microsoft OneDrive. So we're going to focus first on Microsoft OneDrive. I'll talk about it, give you a bunch of screenshots since I can't point to my screen, and you'll see these different files, features, information about the solution, and then we'll switch over to a lab. And once we get to the lab, that's when I'll give you some time to play around with it, and we'll get situated and whatnot. Okay, and so Microsoft OneDrive. So Microsoft OneDrive is baked into every installation of Windows since Windows 8. And so basically what that means is it's pre-installed. The interesting thing is that a lot of the files and artifacts are not there. Even the directory within app data for OneDrive, it's not there until you enable or you authenticate OneDrive. So that's one way that you can tell if someone's using OneDrive or not, is if those directories don't exist yet, you know that in those scenarios, they're not using OneDrive. And so it is there though. So if you do see OneDrive on a system, the service, but it's disabled, that's not that they downloaded it. It's just that it's built into Windows 8 and Windows 10. So you'll see their personal OneDrive folder. If they don't rename it or do any special configurations, it's within the user profile. So see users, Bob in this case, app data, local, Microsoft, OneDrive, logs, personal. The difference with personal versus Office 365 or a business related account is that in that, that directory of OneDrive, you're going to actually see, instead of personal, you'll see business or business 1, business 2, business 3, but the first account they add is going to be business 1 there. Within Office 365, and the reason I don't really focus a lot on the artifacts here is that you've got unified log audit logs. And so if you have a business account, you have, I've seen between 90 to 93-ish days of default logging and retention. I believe you can modify that, but by default, that's what you have. And you actually get a lot of investigation. So on the bottom right corner there, there's a sample of the unified audit logs, and you'll be able to see all the different events, you know, viewed file, downloaded file, and you can ship those for longer retention into a SIM like Elasticstack or Sumo Logic or Splunk or whatever you're using. With a personal OneDrive, they don't even have audit logs. So really we're focusing on endpoints, even if we did get the password to a potential insider threat user's OneDrive account. And so on the left side there, that's what's going to be left behind on the file system as far as artifacts. You'll have .dat files, .ini files, log files, text files, stuff like that that we'll dig into a little bit deeper. So in each one of the cloud file storage solution sections here, I'll have a screen like this, and you will get the slides at some point somewhere. I'm sure we'll talk about that a little bit later. And you'll have this, and this is kind of like a reference sheet that you can have for the different solutions of where things are stored. On the left side, the path or the file name, and then on the right-hand side, you'll see a little bit of detail as best I could summarize what's in those locations. So for example, the first line there, you've got within the user profile, you've got OneDrive, and that's going to be the default location for file stores. So that's where anyone's files are actually going to be. Now, in the evidence that I gave you, the evidence -desktop -q5 blah 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 zip, there I did not extract the actual stores. So I did not extract the files themselves because I wanted to pretend that maybe they deleted the files or you didn't have access to that or they were encrypted or something. I wanted you to really do your investigation with the metadata and not necessarily rely on, well, what's still sitting inside of that folder, because maybe they uninstalled it or removed it or whatever had it. So we're going to really focus on the metadata. As you can see there with the Office 365, the difference will be that the files will be stored in user profile /OneDrive dash and then the company name. The personal logs, basically the root directory for where you're going to find all the logs in the personal case or scenario. It's going to be within app data, local, Microsoft, OneDrive, logs, and then personal. And then similarly with Office 365, it's just business one instead of personal. And then if we're looking for metadata, one of the best places we can go is SyncDiagnostics, and that's going to be within the logs directory. I'll have screenshots of all of these, so it makes a little bit more sense. And then the interesting thing about SyncDiagnostics is that we've got, based off of my testing, we have different results, and I haven't pinpointed why we have different log files for the same name. So SyncDiagnostics sometimes will be awesome. It'll show us all kinds of things. And other times it's more of a summary. And I have some suspicions I'll talk about in a little bit of why that happens, but you may get lucky, you may not in the lab. And then in the app data, local Microsoft OneDrive setting, personal directory, we'll see a .dat file and the CID. So if I've got brackets there around that CID, that basically means it's a customer identifier or a user identifier. So it's a unique string that identifies that user. So they don't use usernames for these. They're using CIDs to uniquely identify this OneDrive or Microsoft account. Within a business account, we don't see that. The CID is a little bit different. I think that's because it's tied to an organization and they're a lot longer. If we look at the cid.ini file, that's going to be where our files are stored. So while it's default, it's going to be in the user profile OneDrive location. It actually can be put in other places during setup. So one of the first places you may want to look at is that the CID of the user.ini, and you'll see that where the files are actually stored, sync times, usage details, etc. And then in a CID dash profile service response.txt, it's going to give us the name of the user, the email, the CID of the user, their email address, phone number, title, other things if they fill out their Microsoft profile, which can sometimes be beneficial. And then in an obfuscation string map.txt file, this one is super interesting. And I still have more details that I need to, or more information I need to dig into on this one. But essentially it's, imagine a spreadsheet with two columns. On the left side, you have a key and they're always in 3 words. So it's like car, bat, sing. And then on the right-hand side, it has an actual name like the username or a directory name. And so it's obfuscating it in other areas where you actually have to map it back to this file and figure out, okay, well, what would actually C/users/Bob be? It's not going to be in plain text. It's going to have these 3-word strings that are obfuscating the actual directory. So I don't know where they get these names from, but it's kind of funny reading down the 3-word strings that you have to map back to, and we'll do that in the lab. So let's dive a little bit deeper into the SyncDiagnostics.log file. In that file, we'll see 2 different types of this file, and I'll get into my suspicion here. So my theory is that you've got these 2 different files. The summary one, which is okay information, but it's really like total number of bytes received or sent or uploaded, whereas the detailed version actually shows you which files are uploaded. And so what I think is happening in my 4 different tests that I did is that I think if you have more than one machine, it kicks this off where you'll have the 2 different files, because every time I've only done one single machine added. So if I create a new OneDrive account and I download or I enable the OneDrive service and I authenticate, I look into the directory and I see my SyncDiagnostics file. And unfortunately, it's just the summary information. But if I use 2 lab machines and I authenticate with OneDrive, the first machine I authenticated with will have the detailed view, and then all the other machines will have the summary. So I think it's only kicked off if you have more than one device syncing, and it will go to the first device that was authenticated. That's the one that gets the detailed log. It's kind of like the master that's keeping record of all the details of the uploads and downloads. But that's just a theory at this point. I haven't had enough VMs to actually verify this. Up until now, it's kind of luck of the draw which one you're going to get, the summary or the awesome detailed version. So on the left side is the detailed version. You can see it's the SyncDiagnostics text file. And very early on at the top of that file, I can see things there like file, folder, and we can see those obfuscated strings. So far, jump, Sue, C, bat, egg, etc. And those are, you don't know what those file names are. You have to go back to the obfuscated strings
text file, and you have to look on the left column, find those, and then see what that equals on the right side to figure out what that is. So that's their way of obfuscating file names so that those file names are not sitting in the logs. The interesting thing, though, is that the logs that, or the obfuscated string key is in plain text as well. So while these logs are obfuscated, you just can go to the other file in a similar directory and you can just grab that and cross-reference it. So I'm not sure of the full thought process on that, but it's interesting. On the right side of the screen, we've got the summary of the SyncDiagnostics file. And so this is if you're not so fortunate, you don't get the actual file folder upload and see all the information of the files and folders that are going up and down. You just get a summary there. So like total bytes downloaded, total bytes uploaded, process changes, total number of files, that kind of stuff. So it's not as useful in an investigation. Okay, so I just scrolled down. This is the summary version again, but I scrolled down a little bit further so you could see the number of local changed files, the number of folders, etc. Okay, and so then I'm going to go back to the detailed version here, and we can see that if I take those obfuscated strings, like there's a folder called cbat_egg, if I go and open up the obfuscated string map text file and I cross-reference that, I can see on the left side there's the cbat_egg, and on the right side it says that's my desktop. So it's saying that some file was, or folder it was referencing is the desktop directory. So it can be a little bit annoying when you're trying to look at the detailed logs and you're cross-referencing them and you've got multiple nested directories and you've got to go back and forth and figure out what the actual directory is. Okay, so we already talked about this, but the obfuscated string map.txt file, it's the way that you deobfuscate directories and files within that log file. Okay, and then the cid.dat file, it's not super user-friendly. And so if we had more time in the lab, what I would actually do is I would give us a tool like strings or B strings or something like that, and I would have us run this against the .dat file, because as you can see here in my sample, there's a lot of other characters that aren't human readable. And so with strings, we can pull that out a bit by number of length or bytes, and then more specifically with B strings, that tool will let you, it'll just extract things that are human readable. So you'll be able to find things instead of all this gobbledygook. You'll see things like travel, itinerary.pdf, and you'll see all the different file names in there. So the .dat file is supposed to have all the file names. However, I have seen cases where I haven't been able to extract file names out of it. So it's a little bit of hit or miss. And I know I'm giving a couple sidebars here and saying, well, it's supposed to, or this happens, and this is my theory. And that's because I have not been able to find a lot of detailed documentation on any of these tools. Probably the best documentation is by SANS, and some of the instructors or research students that they have in their STI program document some of this stuff, but Microsoft doesn't document it. Google Drive, Boxdrops, I haven't been able to find any of the documentation on this stuff. So a lot of it's a little bit of trial error, guessing, assumptions that we have to put into this. So the .dat file, from what I understand, is supposed to have all the files. However, I have seen cases where I haven't seen any of the files that I've added into my OneDrive account. And maybe that's because I don't have two devices that are syncing. There may be certain variables in there that are causing that to happen. Okay, so here's an example where I took the cid.dat and I went ahead and I ran strings against it. And so you can see it's a little easier than, I'm gonna go back one slide, scrolling down in a hex editor trying to identify travel itinerary. And the other downside is you can see those dots between it. So if you do a string search out of the door, you'd have to do t.r. So you can't really do great searching here. But if I do use something like strings or B strings and I pull this out, I can find these directories and it's a little bit more human readable. And then I can obviously pipe this out to grep or other ways of parsing this and getting more information that I'm interested in. So here is a business account, the .dat file, and we can see that rather than, I'm going to go back one slide again, rather than having the actual, what I believe are directories or paths, and then the actual item in question, in the business account, what I've noticed is that certain things you can correspond back to the obfuscation string map, but it's not super clear on how this works. And so if you parse the entire cid.dat, at least in my environments that I've tested with a paid Office 365 account, there was no human readable files or folders. I ended up finding these strings there, and then some of them map back to the obfuscation string map, but some of them didn't. So it's a little bit of a question of how they're mapping those back at this point. The CID.ini file, it's going to give us a couple pieces of useful information here. It's going to give us the library in a personal account, or what they call the library scope in a business account, which essentially is the same thing. It's the CID of the user and then the local path to get to where OneDrive files are being stored. The last refresh time tells us the last sync with the cloud. A lot of the times we're going to take a look at are in Unix epoch time. So I will give you in the lab a way to convert that back to GMT. And then obviously you can subtract right now -7 to get Pacific time here in Los Angeles. So we'll take a look at the refresh time. That tells us the last time it was synced. We may want to know that for certain pieces of information. If we've got discrepancies between what's stored in the cloud or locally, we can see the last sync time. The request sent is the sync activity during the last sync. So how many files were synced, what kind of happened in that last sync activity. That can give us clues into how much data is changing on a regular basis. And then bytes transferred, the amount of data transferred at that last sync there. So if we look at the CID-profile service response file, it doesn't seem to exist in any business or Office 365 accounts. Obviously, I have not tested every level of Office 365, but at least the ones that we use internally, it didn't seem to exist. So it only seems to be in personal accounts from my testing. It contains the display name, the first, last name of the user, their CID, their email address, phone number, title, address, and more. So we can see in my sample ones here, it's Mike Wylie. The surname is the surname is Wylie, given name Mike, the CID of my test account here, the user principal name is going to be my full email address. You could see at gmail.com. If I would have filled out my profile completely with a phone number, job title, stuff like that, we'd also see those things. Okay, and then now we're going to get into registry keys. And so this is the only one that I found, Microsoft OneDrive is the only one that I've seen great value to extracting registry information from. I can, if you want to stay in contact, are really interested in investigating this further, hit me up afterwards on LinkedIn or Twitter by email, and I can give you other files that I have. So what I did is, as I installed the different tools, I ran packet captures and I ran Redshot. And so I captured all the changes it made to the registry and all network traffic that happened during installation, so we could get a better idea of what's going on. There wasn't a ton, as I mentioned, useful information from my initial findings on the other tools. However, Microsoft, being Microsoft, loves the registry, and OneDrive utilizes it heavily. So what I did with my Redshot is that I looked at the different accounts, a Office 365 account, which is the business one, and then a personal account. And then I actually did a compare on them and saw what was common between the two accounts. So you can see the different registry keys that are utilized for a Office 365 account on the far left. In the middle is going to be a free personal account, what information you'll be able to have if you're investigating that. And then where they're similar, you can see there's only one item that is in the personal that's not in the business account. Otherwise, they're the same. Okay, and so some of these registry keys that we'll take a look at, it's going to be in the H key current user if you're looking on a live machine. If you can get a forensic image or a triage image like I gave you, it's not going to, you don't need to go into the H key current user. You can actually go into the user profile. It's a hidden file called ntuser.dat. That's where the information that we're interested for Office 365 is going to be in our triage image. And so I'll explain more on how to access that in the lab. But the registry key user email, which you'll find is the OneDrive or Office 365 username, aka their email address. You'll find their CID. You'll find the team site SPOR or resource ID, and that's going to be if they've got SharePoint essentially is the underlying solution or the underlying technology. So you're going to see the SharePoint URL, whereas if it's a personal account, you'll just see a OneDrive URL. You'll see a key called namespace root ID, which is a unique OneDrive ID. You can use this for obviously forensics, or if there's a court case. All these IDs are going to be useful in demonstrating that it's unique and this isn't some other account. It's always tied back to this one user. The user folder is obviously we've seen other places, but again, it's verifying where the root is of OneDrive, where files are being stored by this user. And then the client first sign-in timestamp, from what I have seen in my lab testing, is that it's the first authentication. So it's the time that you basically activate or enable OneDrive. And obviously it's in UPOC or Unix epoch time. And so you'll need to convert that. And then the last sign in time, OneDrive doesn't make you continually sign in. I seem to have bad luck with my account, and occasionally it'll pop up for reauthentication and a MFA key. But from what I've seen on personal testing, personal drives, it doesn't really make you re-sign in. So what I believe this to be is, since I've noticed it constantly changing, I think that in the background, OneDrive is sending reauthentications, and it's tracking those, because I definitely did not re-sign in every time that timestamp was updated. So that may show you when the computer was turned back on, or when they resynced or re-enabled OneDrive, or if they paused it and unpaused it. That would give you information on that. And then the mount time, again, in a business case, is going to be where the local files are stored on the end user system. And the URL namespace identifies in a business account the SharePoint URL again. Okay, so here's an example. You get a much better way of doing this. I give you a GUI tool where you have Registry Explorer, and you're going to browse through it almost like a real registry hive. But here's an example on my screen just when I ran reg query against HKey, current user, software, Microsoft, OneDrive, accounts, business. So this is my business account. That's why I'm giving you a screenshot. And you can see the different things there, like configured tenant ID, the user email. So there's my Richie May account. There's the team site. So it's Richie May something something at SharePointProbably.com. And then same thing with resource ID. And then the namespace root ID, it's another SharePoint URL. And then the user folder, that's where my data is stored locally. And then the interesting thing is, if we look at the software sync engine providers OneDrive location, it actually shows us what's shared with us. So in this OneDrive instance that I have here, if we go to this registry hive, what we're going to see is that anyone who shared documents with me. From my testing though, it's only showing things that you add to your local OneDrive. So for example, if someone shared something with me, what we need to do is add it to, there's a little button at the top that says add locally. And once that happens, then it will show up here. But if you don't add it locally and you only have it in the cloud, we won't see this. But this can give us instances where someone's receiving shared content, and it's going to be displayed there in the registry. So if you dive into one of those, and on a personal account though, it's not going to have that long string there, like the B736 EEB, blah, 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 blah. It's actually going to be the name, like, project XYZ or test or whatever it is. So it's a little better in the personal scenario. With the business one, I think this is just mapping to an organizational shared ID. And so that's why we're not seeing that. But if you actually go into that key, you're then going to see more detail about what the actual mount point is, which is going to be the local directory for that shared resource, and then the actual namespace or the URL to get to that as well. So that's kind of useful to see what's shared with the users. Okay, and I've got a couple more slides here, and then we'll jump into a bit of a break. With the on the personal account there, looking at that reg key for software sync engine providers OneDrive, within there we can see, unlike, I'm going to go back to the other one there where this one says it's personal one. These were some long string, which I think maps back to the organizational's internal IDs. This one here shows that it's actually, you can see OneDrive/personal. And so it shows you the actual name of that share, which is even more useful from a higher level view. And then the bottom screen there, I'm showing you that in order to see this, in order for it to show up in the registry from my testing, you have to go to the cloud and then press the button. It doesn't have to be on this machine or the machine you're investigating. Any machine that the OneDrive is installed for that user, and you press add this shared folder to OneDrive. Once you click add, it's going to sync this registry key with all machines that are connected. So if we dive into that further, we can see the actual CID of the user that shared that. So in the bottom part of the screen, if I go into that test shared directory or shared file, we've got the CID. So I can now see who shared that and map it to a unique person that shared it with this user, Bob. Okay, and then last piece here, I believe before we go on break, is that Microsoft has a couple different pieces, and some of the other providers are doing this as well. But early days in a lot of these cloud file storage solutions, you just basically downloaded everything, and it caused a major issue with too many files on everyone's local file system. Some of the providers allowed you to selectively sync certain directories. Microsoft lets you, since it's built into, OneDrive's built into Microsoft Windows, is that you can right click on a file and you can free up space, keep this online, you can have it cached only. And so those different icons in the status column within Windows Explorer will tell you whether it's cloud only file, a always local file, so it's always on the system, or if it's just cached on the machine. So that'll give us different evidence as well when we start diving into this stuff. All right, so what we're gonna do, I believe, is take a break. And then, Victor, did we want to talk about the lab first, or we want to do a 10 or 15-minute break and then talk about the lab maybe at 1 o'clock?
Yeah, let's take a 10-minute or 9-minute break. We'll be back at 1 p.m. if that's okay.
Yeah, sounds good. So I'll stay around for about 5 minutes here, answer any questions if people have in the chat, and then I'm going to grab some water for myself and be back at 1 o'clock to do a walkthrough of the lab.
Awesome, that works. All right, guys, if you have any questions for Michael, please go ahead and post in Q&A. So, Michael, we have a question. Is the CID the map to a particular user who shared the drive?
Yes, absolutely. So it's a little bit less useful if in a personal scenario where it's not going to show you the actual username of the person. So if I go back on my slides here, when it shows you dive into that test directory that was shared. So what I did is I created a new account called like Mike.Wylie test2 or something like that. And I shared a OneDrive directory called test. So on Bob's machine here, you're looking at the registry key and you can see that there's a test directory that was shared. And if you expand that and do a reg query on that test directory, you'll see that CID. And that CID, the B Bravo F730 Echo Foxtrot 4 Delta 5707 redacted 88. That number there, that CID, is uniquely identifies the owner of that shared folder called test. So it's not Bob, because we know Bob's CID. It's someone else. Unfortunately, it doesn't immediately tell us, well, this person's CID maps to this email address, for example, mike.test2@gmail.com. So we don't get to see the actual email address of that test user. But if we happen to find it another way, whether it's through an online account or one of the other databases or an email or some other way, we can then associate those two. Then we can always uniquely identify them here. Because, for example, with Gmail, you can type your email in different ways. You can do mike.wylie@gmail.com. You can do mikewylie@gmail. It lets you do it a couple different ways, but that CID, it's almost like I don't want to call it a hash, but it uniquely identifies the owner of a file, a folder, a OneDrive account. I'm going to show the Word document here first and just make sure everyone has this one. So if you have not seen this one, this is in the Git repo. And it's pretty simple. It's what you need for the lab. And if you don't have this set up now, you can obviously do this another time at home. I have some detailed walkthroughs in the lab instructions. So it works on a Windows machine, but if you have a Mac or a Linux machine, if you want to use different tools, go ahead. I just didn't want to try and support every different type of operating system here. So what you're going to need is a SQLite viewer. And so the preference that I have and the installer link here is DB Browser SQLite. Before you go clicking on this though, I've packaged all these tools at the bottom here. If you go to the S3 bucket, at the bottom of here's the lab files, but then there's also the zip file of all of the 4 different tools you'll need. So we need the SQLite database browser. You need a heavy duty text editor like Notepad++. You need a hex editor, 010 or HXD is what I use in the walkthroughs. And then we need something to parse the registry keys. And so what I find works well is Registry Browser by Eric Zimmerman. So once you have those tools installed, that's what you're going to need aside from the lab files to do everything. So you could do it on a VM, you could do it on your main machine. There's nothing malicious within these files. So once you have those installed, you're going to need the evidence zip here. And from what I've heard from people, if you joined late, is that to decompress that or extract that, Windows Explorer doesn't like how long the file paths are. So 7-zip is something we should add here as another tool here. So if you get 7
zip, that should be able to extract the long file paths that we have there. So once you have that, you can go ahead and follow along. I am going to do a quick walkthrough, and then we also sent out the links, or I think it's in the GitHub repo as well, for the labs. So let me switch over.
Yep. Everything is there, and we'll add 7-zip, and we'll commit to Git again.
Okay, and then before I go to my Windows machine, I'm just going to show this, what the first document looks like. So this is the one that you want to have open. And the way it's set up is that we're working on the Microsoft OneDrive lab here. You've got the lab instructions. And at any point, if you feel like I'm not getting it, I don't understand it, you know, whatever problems you're having here, you can scroll way down, way down, way down. And there is a section here with a detailed walkthrough. And so these have all the screenshots and the answers built into them. And so if you need some help there, because I can't just come on over and look over your shoulder, you should probably look at that first. If you still have problems, please reach out with the questions and answers, and we'll get to those as quick as we can. But you're basically going to walk through. Everything's going to be, you'll see the file paths that I use for everything, because I don't know where you're extracting it to. I've got a ... in front of it. So wherever you've extracted this evidence desktop directory here, then within that you have what's essentially, this is like a Windows machine file path. So you've got C for the C drive, then it's the users directory, and then we're going to look at Bob, and then app data. So it's basically, imagine this is the end part here is what a Windows machine would look like if you were actually on Bob's computer. So wherever you extracted to, this is the key points of his computer that you have now on your machine. And as I mentioned at the end of the workshop, I'll show you how I did this, but let me switch over to my lab. Okay, and now, yes, I am using Bob's computer, but as I mentioned, you don't need Bob's computer because I gave you all the key things that you need. And so what that is I've got this evidence desktop Q5 blah, blah, blah zip file that you have. So I'm gonna go ahead, right click 7-zip, and I'm gonna say extract files. And then I'm gonna put it here in a directory called demo. I'm going to go in there. And so now inside demo, I've got this evidence desktop directory. So this is where we're starting here to look at the machine. So this is like the triage image of Bob's computer. So when you click into that, you see, you don't even pay attention to these log files. This just talks about how I collected the evidence and the log of that. But you've got the C directory, users, Bob, and you can dive into some of the stuff there. So I am going to take a look here at on my other screen, the instructions, so I can give you a walkthrough and make sure it's accurate to what I am telling you to do. Give me 1 second. Okay, so I first tell you to navigate to the CID profile service response. So almost everything for these cloud solutions, aside from Microsoft, where it's got some things in this NT user hive, it's going to be inside app data, and then local, and then Microsoft, OneDrive, and then I tell you to go to settings, personal, and then, so as I mentioned here, these this number here, the 873851, whatever this is here, that's going to be the CID of the user on a personal account. So we already have the CID user. In a real investigation, I'd start documenting this and say, you know, we've identified the CID of this this OneDrive account, put that in my log file. Generally, it's a spreadsheet that I'm working on. But on the first instruction here, step 1, I tell you to do CID-profile service response. So we can see that it's this file right here. I'm going to right click on that, and I'm going to open it in Notepad++. Okay, and it's a little bit, let me see if I can zoom in a little bit for everyone. If you zoom in. Okay, and so I'm going to scroll all the way to the left, and it's a little funky to read here, so I'm just going to start pressing enter so we can see what this is. And it looks like it's comma delineated here. So every time I see a comma, I'm just trying to press enter. I think I deleted everything there. Comma, there's a comma, comma. Split this up. I missed one here as well. And this just makes it a little bit easier for you to read. Okay, so we've got here the display name. So it's Bob McLeese. We verify that this is our suspect here. Surname McLee, first name Bob. Okay. Now we have our CID again here. So this matches what we saw in the directory there, in the personal directory. We see the email address that Bob used. This matched what HR gave us. Unfortunately, we didn't get the phone number or title because Bob didn't fill that out on their account. So the question is, what's Bob's CID? We saw that before, but we verified it here. So you can copy this and paste that as your answer. The next question is examine the profile service response and get the principal name, essentially the email address. So we pull that out. We've already looked at that. Then we're going to go ahead and take a look at the sync log or SyncDiagnostics.log here. So I'm going to minimize OneNote, and I am going to look for sync. I think it's in a different directory here. It's going to be in log personal. So get out of there, go to OneDrive, logs, personal, and we are looking for SyncDiagnostics. So I open this up, and we can see that if I scroll down here, I've got the app ID, files to upload, this kind of stuff. Scroll down. It looks like, unfortunately, in this example here, we did not get the detailed version. We only get the summary. So I can't definitively say that there's no other devices synced with this a OneDrive account just by saying that, but that's kind of my assumption at this point. And at least we can see how much activity that the user has. So where's the number of files? I think it's up higher. Number of drives. There's 3 folders, 13 files in their account. Okay, so we can get some basic information, the instance ID of their OneDrive account, a couple pieces here, but not as good as if we had the detailed version of this, unfortunately. Okay, so let me go down. There's a couple questions to answer in this file, like number of files, folders, stuff like that. So you can answer that there. I'm then going to open up the obfuscation string map. So I'm going to close this. Here's our obfuscation string map. I'm going to open it in Notepad++. And here's what I was talking about as far as the different folders and file names and how they map here. So if we're looking for the app data directory right here, that the key for that in the other logs, if we were to have the detailed version, would be tax, zig, pen. And so, for example, C users Bob, if it's a directory path like that, it would actually be joke yak log / rod oaf gad, and then orb rich fish would be the directory path that you'd see in the detailed log file. If there's reference in the log file to login.live.com, it would be 8-bar dodge or doggy or whatever that you're going to pronounce that as. So it's kind of interesting if you just parse down here, even if we don't have the detailed version, we could start looking at stuff like, okay, there's the email address. There's, I believe this is the CID again. This is stuff that we saw in the INI folder, or sorry, in the last text file we looked at. But you can also start looking down and just see if there's any other keywords that are possibly standing out to you. Let me just search for one if I can remember what it's called. Okay, so looking at some of these here, we could see draft client email, business plan 1, resignation letter. So just looking at this is what's meant to be a mapping between obfuscation and a real folder name actually gives us some interesting information on file names and possibly some interesting file names that we may want to put in the back of our mind or put in our notes and come back and try and see, well, can we find caches of these? These are some interesting things that we may want to look at as part of this investigation. Okay, so the next part is we're going to look at the, let's see here, the navigate to settings personal. We're going to look at the CID file. So I'm going to minimize this. Go back to settings, personal, and CID.dat up here. I'm going to right click. And I'm going to open this with a hex editor. The HXD is the one I told you to install. And I'm doing that just because if we do it in Notepad++, it'll be absolutely crazy. And if we use strings, it would be even better than a hex editor, but at least we'll get a little bit of a view here. Okay, and you can see there's a bunch of gobbledygook. And this is why I like to have use something like strings or B strings, just because I don't have to manually sort through this as much. Right, but we can see certain files possibly here. Let me scroll down and find something a little better. And I would do a control find, but because of those dots, it's going to drive me crazy trying to do. But I can see here the Mike Wylie. Can I make this bigger for you? Let's do a view. It's got to be a way to zoom in on that. But what I can see here is
I think in view.
In view.
In view, I think. No. No, mind.
Tried the usual control plus, and now I even lost it. But I can see here the Mike Wylie website SSH keys.txt probably. So you can kind of find things there, but this is not how I would really do it in the real world. I'm just trying to have you manually look through this to see what it looks like. In the real world, as I mentioned, strings or B strings, and piping that through with find or grep or other things and trying to get a better idea of this. This is, in my opinion, this is pretty sadistic to manually parse this. But it's just for illustration there. So you're going to go ahead and take a look. There's a couple of things you're going to look for is folders I'm asking for. So you'll look through that. I give you an example of the first folder. You're supposed to find the second folder that is synced. And then I'm going to go to the cid.ini. So I'm going to minimize this. Here's the cid.ini, so right click, and I tell you to open it in Notepad++. Okay, get rid of my find here. Okay, and so within here, we get some information. What am I gonna ask you to get? It is, what's the local path being used to store OneDrive files? So we can look through here and we can see up here the library. It's, for some reason, they're still using SkyDrive, which is what they called it like 10 years ago. And this folder, so there's somewhere, something's being logged and they forgot to update it to OneDrive. But then we could see me personal directory. It's located in C, users, Bob, OneDrive. So if we had it and it was within our scope and we we're allowed to do this, we could try and go to this directory and grab the original files. I didn't give you those because we're going to look at metadata in these labs. Okay, and so now I want to show you how you're going to do the registry stuff. So I'm going to minimize Notepad++. We've got, I'm going to close out of it. Okay, so I give you Registry Explorer. It's a little bit slow, so just click on it, or right click and open and let it do its thing for a second here and let it open up. And then if you get prompted for, it may not do it since I've already accepted it, but if it asks you basically that Microsoft Defender Smart Screens is preventing it from running, it's an unrecognized app, you could press more info and then run anyways. So if you don't press the more info button, it'll basically say don't run, but if you click on the more info, it'll let you run that. So you don't see that on my screen because I've already run it once. I do show you screenshots in the lab of how to get around that. So if I was on a live system, I'd probably use regquery or some other tool of extracting this, but because I basically got that ntuser.dat file for you, we need some type of tool that will read this. And I tried to find a way for regquery and other tools to read the registry hives that I extracted for you, and it just wouldn't work. regquery, from my understanding, is only doing it on the local system or remote, but you cannot point it to a unique path. So I had to find a tool like Registry Explorer by Eric Zimmerman. It seems like all the cool tools are written by him. If we go to File, Load Hive, this lets us pick the hive. And so what we want to do is go back to our evidence. So I have it in Downloads, Demo, Evidence Desktop, C, it's going to be in the user Bob directory, and then right there within the user profile, we see ntuser.dat. And so one quick thing to mention about this, it's way outside the scope of this workshop, but just as far as forensic stuff, is that the ntuser.dat is frequently dirty. And what that means is it's got journaling. So these logs here, log 1 and log 2, are used as journal for things that were not fully committed to ntuser.dat. And normally things are written there once the system's rebooted. Because I did this acquisition live, we have those journal files of things that need to be written to ntuser.dat, but they didn't have a chance to because I pulled everything while the system was still online. So when we try and open ntuser.dat here with Registry Explorer, it's probably going to give you an error that it's a dirty hive. And so let's walk through that. So if I click open on ntuser.dat, most likely, there it is, dirty hive detected. And basically we're going to say, yes, we want to replay those log files against the Hive to record those transactions. So I press yes, press OK. And then it's going to say here, which logs do you want to use? I'm going to say both of them. So I can just, control click on both, or I can drag my mouse over both of those, press open. Okay, transaction's been replayed to user.dat, press OK. And then it says, well, where do you want to write this clean one to? Doesn't really matter from my testing, so I'm just going to put it inside the root of the demo. I'm not even going to put it in the evidence. I'd probably steer away from putting it inside your evidence folder, because now you're putting other things and introducing it into your evidence. So I'm just going to drop it right next to the evidence folder here, user.dat_clean. Okay, and it says the Hive has been updated, the sequence number is made to match. Do you want to load the updated Hive? I sure do. Press yes. And then do you want to load the dirty Hive as well? No reason if we have a clean Hive, so I'm going to say no. It doesn't matter if you say yes, it's just going to show another version under this. Okay, so now that we have the Hive there, we can look through this almost like looking at regedit. And so let me catch up here and see what questions I'm asking of you. Okay, so I ask you to go into the root of this nt_user.dat or nt_user.dat, and then go into software. So we're going to expand software, and then expand Microsoft, and then let's see what the questions are asking for. Okay, inside then OneDrive, scroll down. I've skipped it. There it is, OneDrive. Expand that. And then within here, we have accounts. And so in this case, I only see personal. If it was an Office 365 account, you'd see business one, and you could click on that. So if I click on this personal one, what's interesting here, let me make Registry Explorer bigger and move this so you can see a little bit better, is that we've got 22 different values in this inside here. And when I can see things like user folder, so again, we can verify where things are stored within OneDrive. We can look for things like the CID of the user. Okay, so here's the CID. We can look for, let's see what else, the namespace root ID, so the ID of their OneDrive instance right here. Okay, we can see the last sign-in time right down here. And we can see the client first sign-in time, which is down here. Okay, and so as we can see the data here for the, let's say the client first, or let's say the last sign-in time, it's 1587. So anytime you see something that starts with like 1587, it's Unix epoch time. And so what we're going to do is I'm going to right-click, copy value, because I didn't make it copy data. I didn't make it so easy where it's just give me the epoch time. I want you to convert that. So I'm going to open up Internet Explorer, my favorite browser, and convert Unix epoch. In the lab, I give you the actual link. Okay, and so what I do is I just paste in the value here and make it human readable. And so it says GMT time is April 17th, 1 p.m. We subtract 7 to get whatever time it is in Los Angeles. And so it actually does that for us right here. But I generally, in my investigations, I keep it as GMT. And the reason for that is it gets super confusing which time zone you're at. And so the drift can be an issue when you're investigating, especially if they have devices in different time zones or they took it to different locations while they were working. I try in my spreadsheets to always use GMT. So when I have a timeline that I build in Excel, I'll have my first column is time and GMT. And I can always do the offset later on. And if I need to go to court or whatever else, and I have to say local time, I can do that. But I have worked cases with other people, and it was incredibly confusing when people were putting times in, and I would ask them, well, what time is this? Did you put it in local time, GMT, when they were in New York? And we have no idea, and we ended up having to do a lot of rework because we didn't put the proper time in. So if we all just agree on GMT and put our times as evidence in GMT, we can figure out the offset if needed later on, but it's a standard we're working off of. So I ask you for the GMT and the local time, so GMT -7 in Los Angeles right now. So we've got those two times. So this happened at 6:09 a.m. the day that Bob gave notice was the last sign-in time. So we can see that Bob was on the work computer doing something, potentially in OneDrive at 6 in the morning yesterday. Okay, so that answers that question. Let me go down to the next piece. And so then I ask you to go to software sync engines provider OneDrive. So I'm going to back out of this. Okay, so it's software sync engines. So down here, providers, OneDrive, and then we see within here, within this OneDrive directory or key, I've got different things like the personal one, which is default when you have personal OneDrive, but then there's two other folders. So now we're getting insight without even having access to the user's OneDrive root location. We can now see that there's a finance directory and an operations directory with that user. And then within these, we can also see where that's located, the mount point. So it's in the OneDrive location, which we'd expect. Same thing with this one here for operations. We can get the last modified time. We can get the library it's in, the CID of this, and so on of the owner. And so we can get some more information about these to see. And so one thing here, maybe someone can post in the chat, does this CID match Bob's CID or is this someone else?
All right, great question. Let's do it.
So again, the question is, the CID I have here on the screen, it starts with E94 and ends in DC8. Was that a same or a different CID is what we saw? Okay, Mary says, no, it does not match, and that's correct. So we saw that before, but here again is the CID of the user who shared this. So we have another way of verifying that there's 4 directories in Bob's OneDrive account, and we can verify too, if I click on the personal here, this was Bob's CID. So we can see it starts in 87.3 and operations starts in Echo 9.4. So this is a different owner that owned operations and finance. And what it turns out is actually these were owned by the Mike Wylie LLC. And so these are legitimate in this case. Okay, so let me go down a little further. And I actually think that is the end of the Microsoft lab. So I try in these labs is give you different different things to kind of poke around, and then in the end we start discovering a lot more of information related to the investigation. But I want you, obviously I've used the same files in each of the tools, so I don't want to give you all the answers in Microsoft, but you could get all the answers and all the files in each one of these solutions. We just want to play around with different ones. So I'm showing you different areas to get different answers and different pieces of information, and it'll kind of come together a little bit more once we dive into the Box lab.
So Michael, we have a question before
Yep.
we jump in. Yep, go ahead if you want to take this.
Okay, so the question is, does this mean there were 2 users on the same system or 2 users had access to the same drive? So what this is telling us, or what we can deduce from this, is that that these 2 folders are within Bob's OneDrive. So if you went to his system, C users Bob OneDrive, that location, you'd find 2 directories. I'm sorry, 3. One would be finance, one would be operations, one would be personal. The personal one was created by Bob, or it's actually just created by default in Bob's OneDrive account. But then finance and operations were 2 folders that were shared with Bob. So he's not the owner, someone else is the owner. The owner is, we don't know the email address at this point, but it's E94235 blah 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 is the ID of the owner of finance and operations. And so in my scenario I set up, those are actual accounts, as I mentioned in the case on one of the early slides, is that unfortunately the company was using some of these file storage solutions, the free accounts, to share files internally. So those are legitimate ones. We're going to find a lot more illegitimate things throughout the next couple of labs. But the only thing we can really say is that finance and operations were owned by someone else and shared with Bob at some point. Cool. And then Victor, how long do we want to give for this lab?
So we can go for next at least 20 minutes.
Okay. Sounds good. So then probably a little, I'll check in with people, and if you have questions, post them here, but we'll probably give until then, 1:50, a little before that, maybe 1:45-ish. I'll check in with everyone.
1:45-ish.
Okay,
Perfect.
yeah, 1:45 I'll check in, but as usual, post things and let me know how I can help you if you have other questions on this stuff. Okay, Jeff's got a question here. Even though OneDrive is a cloud service, it still leaves information on the local machine. Yeah, Jeff. So the scenario that we have here too is that OneDrive was authenticated to Bob's machine. So at the very end of this, my slides, I do talk about a scenario where they don't have the client installed on the machine. I talk about a scenario where you don't have that information and you can look at some web browsing history and you can get some insights, not a ton, but some insights to what they're doing in those different solutions. But yeah, Google Drive, OneDrive, Box, all those different solutions, you could either go to their website and upload, download, view files, share files, stuff like that, only using a web browser. But a lot of them are a little bit limited, and you can't do as much of the real-time collaboration. A lot of people will use it to sync. So they install the client, or in the Microsoft OneDrive scenario, it's already installed. They just authenticate, and then everything in their online cloud OneDrive then gets synced locally to C users Bob slash OneDrive, and everything is then also local, or at least a cached copy is local, or the file name is local. And then as soon as you double click on it, in OneDrive's case, it then downloads the rest of the content, and it's now fully on the disk of that end user's machine. So it depends on how the user uses it, but I would say a majority of the time where we see stuff is either they're logging in and then uploading data to exfiltrate it out of a corporate environment, or more often than not, I see where they download Dropbox.exe, install the executable, and then they're syncing files. And so a lot of this information then is there. And so what might help too is if I share my lab machine again, and I'll show you exactly what this looks like. And so I didn't want you to see this, but if I go, this is Bob's machine here. And if we go to, as I mentioned, it's C:\users \, and I can even do, I'm not even typing, hold on. Okay, C, actually I could just do parentheses signs. This is environment variable, user profile. So this is the logged in user. Of course this doesn't work. Hang on. If I do C:\user, I shouldn't need to do that, but, oh, I'm missing this, that's why. Well, demo fail. There we go. Okay, so it automatically, the user profile is C users Bob. And if we look here, there should be a OneDrive. If I click on this is what's in Bob's OneDrive. So it kind of answers some of the questions later on, which I didn't want to show you, but we see the finance and the operations directory sitting here. And then there's other stuff within there. So this is how he has it set up. And if you delete something here, like this folder, if I right click and do delete, it's going to delete it on the cloud. So they're syncing back and forth. The actions you take here are going to most likely be taken on the cloud, and vice versa. If I logged into OneDrive.com and I delete the folder there, it would then, as it syncs, it would tell it to delete it here as well. So a lot of this stuff, Microsoft does it in a lot of registry keys, but all the other solutions do it in a SQLite database where it keeps track of where did the action start with? Did the cloud say delete it locally, or did the local say delete to the cloud? And it has to then keep track of that and sync that. So hopefully that answers your question, Jeff. Another question here, can you determine which files were online and offline based on the metadata we have? Yes. Inside of Microsoft OneDrive, I'm not 100% sure off the top of my head how with OneDrive. The other ones, you'll see that. There's definitely with Box and Citrix ShareFile and Google Drive, they're all SQLite databases, and they frequently will have indications of where it started from, and also which ones are available locally and not, which ones are cached. So you get a lot more information with the ones that use SQLite databases. I can't think of where Microsoft OneDrive keeps track of that off the top of my head. I can go back and look into that a little bit.
team, if you're following along the workshop lab, if you have any questions, feel free to post it in Q&A. Nice. Thank you, Dimple.
Yeah, and if you got questions, feel free to bring it up. When you are done, if you could let us know in the chat or something like that that you are done with the lab, that helps out. So we're not making everyone wait if everyone's done. Hey, Trevor, so question is, I'm seeing your side versus the logs. It says 3 folders are being synced, and I see 2 with something deleted or hidden in the folder. So I think that's mapped to this personal vault, possibly. And we can even log in here to the OneDrive online and see if it's there. And it is possible I deleted it too. I tried to clear everything out before adding everything, because a lot of them, they had like getting started guides and things like that, and I didn't want there to be different data across the different platforms. So let's log in and see. It's funny too, Microsoft was the strongest password requirements out of all of them.
I know. I was talking about it as well.
All the other ones let me do like lowercase, and theirs didn't, but. So I think it does map to this personal vault. I think that's what it comes down to. And we did see the shortcut to that as well. And some of these things as well, this one doesn't look like, it looks like a true symbolic linkish open. So here it says, yeah, account type equal personal. I'm guessing it maps to this one. Some of these things like Google Drive, it doesn't actually download files or folders. And it really threw off in the Google Drive lab, because the finance and operations folder, because they were shared from another account, it made them, what extension? It gave them G. It doesn't even show up here, does it? Oh yeah, operations.g shortcut. So it didn't even do a full folder, and the files within them didn't get copied, right? So that one drove me crazy. But the rest of them, it's kind of interesting, and I don't know which ones I have to figure out. Trying to remember which one's which. But there's some here that business plan. I think all these were local. If you look at the actual file, and maybe it was in a hex editor, it's not actually even a file. It's really, I think, like a parse point or a shell that then redirects using JSON to the URL of the Google Doc or something like that. And it wasn't just actual Google Docs, it was real documents as well. It was doing these shells, and they weren't actually like docx files. They were just shells. And I can't remember how I did that without actually opening it now in the moment. But it was kind of interesting that some of those don't actually download the full file, and they actually create parse points or empty shells or text files instead. Okay, I've got probably another 2 minutes-ish, and then we'll move on. How's everyone doing with the labs?
Sure, they're doing good. If I don't see any, oh, there is. All right, Microsoft Lab done. Nice. So, folks, if you guys want to take a break as well, just take a 5-minute break so that we can start the next lab part. Jeff cannot find cid.dat.
Okay, let's see. Let me try and pull it up on mine, Jeff, and make sure we're on the same page. So I got my demo, evidence, C, users, Bob, app data, local, Microsoft, OneDrive. I think it's in settings, personal. So it should be, I'm going to put this in a text file so you can see the full path. Let's do, and actually, maybe this is probably more helpful if I put this in the chat too, or send this to Jeff. Jeff, I'm replying here in the Q&A. That's the path that I see it on mine. And the CID is going to be that number that starts with 873. And just keep in mind there the path that I sent you, the first part, C, users Bob, downloads demo. So that first piece there, you may want to just replace. But once you look at that evidence desktop directory, everything else should be the same. C, users, Bob, app data, local, Microsoft, OneDrive, settings, personal. Okay, question is upgrade available and registry is 1? Does that mean Microsoft was not a recent version? It's very possible. I didn't really change any default settings. I did get the ISO. I downloaded it from Microsoft's website earlier this week, and so I left everything as default as far as that. And a bunch of the things during my lab, and this is why I was delayed in getting the slides and labs ready, was that mid demos and labs that I was recording, they all of a sudden updated and things changed. So it drove me crazy, and I had to try and like actually disconnect from the internet to stop things from updating because some of them wouldn't let me stop the upgrades. So it's possible that OneDrive wasn't the most recent, but I can't say for sure. I'd have to kind of compare probably some of the information in one of those files or the registry keys to current version that's offered by Microsoft. I have also seen where it says Microsoft's out of date or OneDrive's out of date, and you go download the latest version from OneDrive.com and you try and install it, and it won't let you. It says that it's already installed, which I found kind of interesting as well. Like if it's always available or it's always baked into Windows 10 and Windows 8, why are you even giving me the option to download it if I can't replace it? And then Jeff, I found it, but the offset doesn't go down to 0073. So Jeff, are you saying you found the .dat file? Oh, you found it. Okay, good. And Victor, do we want to kind of move on or give people a few more minutes?
Yeah, so we'll begin 150.
150. Okay, so we get a few more minutes, 3 more minutes. Any other questions? Keep them coming. I'll be around.
Michael, we have 2 more labs left, right?
Yes, the Google Drive and Box Lab.
Okay. So we'll do 1 lab, we'll do 5 minutes of break, and then we'll do last lab, and then we'll wrap up.
Okay.
Yep. We'll begin at 150. And quick reminder, attendees, if you would like to get a hold of these slides and recording, please make sure that you are subscribed to our social media platforms, LinkedIn, Twitter, YouTube. It'll be posted over there so you can get the notification and view it, watch it, and learn it.
Bunch of hardcore attendees to be here on a Saturday looking through logs and registry keys.
I know, right? That's what I'm talking about. These are the people they teach us in the books. Determined and hardcore people.
I love it. I love it.
Go ahead, finish your sentence. You were going to say something.
I was going to say, normally with these the in-person workshops, we've you get maybe 20, 30. So it's awesome to what you guys are doing, and all the people who are interested in learning that they're here on a Saturday.
Awesome. Yeah. Well, all thanks to you. All of
Likewise.
Yeah. All right.
Shall we?
Let's do it.
All right. Let's take a look at Google Drive now. Hopefully you all got refreshed and bio breaks. The Google Drive one's a little bit interesting. It's the first one we're going to start looking at some ways of storing data in databases. I did not look too much into the business platform, the Google File Stream. I do have a G Suite account, but due to time constraints, you can see there's too many variances. So I worked on mostly the personal version, which now they've renamed again to Backup and Sync, but I'm going to call it Google Drive just because I like to. So Google Drive was formerly Google Drive. Now it's Backup and Sync. The business version is part of G Suite. It's called Drive File Stream. The backend, rather than using registry keys and whatnot, is they use SQLite databases. And then artifacts on deleted objects is a bit limited. It seems to be purged out pretty quickly. The one thing I forgot to mention about OneDrive and pretty much all the platforms sort of tested, I haven't done thorough testing, but it seems like they all, if you delete items, whether it's local or through the cloud, they go to the recycle bin in the respective. So in the cloud, it should be in the trash or the recycle bin or deleted items or whatever for a certain period of time, generally between 30-ish to 90-ish days, that you might be able to recover it. And then locally on the system so if you're in the cloud and you delete something, it's going to trigger that delete on the local file system of the endpoint. So for example, Bob's machine, and it throws it in the trash, the recycle bin on the Windows machine. So users may not realize that. They may see it's gone from OneDrive, it's permanently deleted. I think one of the platforms does have like a hidden folder called trash that's within it, but most of the time things get shipped off to the Windows recycle bin, and you may be able to recover files there. The interesting thing about the business version of Google Drive is that it actually creates a virtual volume in FAT32 and it mounts it to the file system. So it's like a virtual thumb drive essentially. The other one that did this as well that seems unique is Citrix ShareFile. So Google Drive and Business and Citrix ShareFile seem to create virtual volumes and mount them for you. And then there's obviously a lot more logs in the G Suite admin portal if you have access to that on the business side. Synced Google Drive or synced Google formatted drives. So like your Google spreadsheet, your Google document, and your Google PowerPoints or Google presentation, I think they call it. They're really interesting because they create a shell, and so it's not an actual file, even if it looks like a spreadsheet there, like I have budget, for example. If you open up budget with a text editor or a hex editor rather than double clicking on it, you'll see some interesting things like a URL, a doc ID, and an email address. So that's one quite interesting thing that if you click on it, it actually goes to that URL. So you'll be able to see that, and possibly if they didn't protect it and it's shared with someone else or anyone with a link, you'll have the URL to that document right there. So here's your cheat sheet again. You've got the default location is user profile / Google Drive, and in the business version, it's mounted. And then You've got within app data, local, Google Drive, user default, you have some databases. And so you've got your sync config, which has user info, preferences, initial application, install information. You've got the cloud graph DB, which is metadata for local, cloud, and shared files and folders. And then you've got some interesting logs like the sync log, which tells you when files are added, deleted, modified, and renamed. And then snapshot.db, which is local file metadata only. And then for business users, you have a Drive FS directory. And within that, you have a couple interesting things like cached content that's cached locally. And then you also have metadata SQL DB that you could take a look at if you have a business account. But we're looking at the personal ones in the lab. So let's first take a look at the sync config DB. Within the DB, the database, for those of you who are not familiar with looking at databases, we need to also specify which table within the database. And the way I explain database to those who aren't super familiar with them, imagine the database is the name of a Microsoft spreadsheet or an Excel file, right? So sync config is the actual file name, but if you ever worked with spreadsheets or Excel files, in the bottom, you've got those tabs. And if you think of the tabs, those are almost like different tables. And so you can flip between those different tabs, which hold different cells, different rows, different columns. That's the best analogy I can give as far as the database. So you do, when you open up the sync config database or any of these, you want to parse through or click through the different tables because some of them are blank, some of them have interesting things in them. So in the data table, this is the only one that's configured this way. There's an entry key column, and within that, we can look at a couple of the different rows, like highest app version, so it tells us which version's installed, and that goes to someone's question earlier in the Q&A when they asked, well, was this up to date? Well, if you go into Google Drive and you look at the highest app version and you compare that to what's released, you could see if it is the right version or not. Local sync root path that tells us where Google Drive documents are being synced to the local file system, and then user email, we could see what email address they have associated with their Google Drive account. So here is an example of what that'll look like. And so when we get into the lab, I'll tell you how to use it, but you're basically going to open up the DB browser for SQLite. You're going to find your sync config database, and then you're going to, and highlighted there, the table section, you're going to pick which table, in this case, the data table. And then you'll see it almost looks like a spreadsheet, right? You've got the different rows and the column, or the rows and columns, and you see all the data here. So that's what we're going to take a look at in the lab. The Cloud Graph database, and specifically the Cloud Graph entry table, has things like doc IDs. This gives us unique IDs for each file and folder within Google Drive. So it's pretty verbose as far as what we can see, or what we have access to, or what file names and IDs the files have. We get the actual file name, which is pretty cool. We get the modified time, so when the what time the file was added to Google Drive, again in Unix epoch time. So if they had it at their local file system, they copied it over. We can see when that happened and when it was introduced into the Google Drive environment. ACL role will tell us 0. You'll see a 0 if it's owned by the user in question. And it'll be a 1 if there's someone else, so it's shared. So that tells you if who owns the document. The doc type, this is pretty cool too, because in the file name, we don't see file extensions, we just see the name of the file. The doc type column will tell us what type of document it is. And so from my research, I haven't done every single type, but I've played around with this, and you could see that 0 is going to be a folder, 1's going to be a traditional folder like a text file or PDF, something you normally see on a file system. 2 through 13 are Google files, and more specifically, 2 is a presentation, 4 is spreadsheet, 6 is a Google document. A couple questions here. So when doing cloud forensics, you generally get access to user accounts or make conclusions based off metadata and evidence. So typically we get these, it really depends, right? Because you have some scenarios where it's an Office 365 account, and those scenarios we get more verbose logs from Office 365, and I ship those typically into a SIM like Sumo Logic, and I'm looking for key things in real time, like sharing files outside the organization, access to honey files that I've planted with like fake credit card numbers, things like that trigger events for me to investigate or my team to investigate. But if I don't have the other scenario, and that's why we're focusing on this, is there has been plenty of cases where there's employees that used Google Drive or Dropbox or whatever, and and it was not company issued. It's a personal account, and we don't have access to the cloud. So in those cases, this is all we have access to. Sometimes we do, and I would say most of the time we do have access to what they left behind in their Dropbox account if they didn't remove it. But whether they removed everything from Dropbox or uninstalled it before we got to it is a flip of a coin. So I always try and start with this, and it's a little bit more factual if we have all this metadata versus trying to trust what's inside the Google Drive folder itself. And also seeing what's inside the Google Drive folder, we don't know when it was added, when it was removed, who owns it. All we see is a file name, and we can open it, which is helpful. But a lot of this other stuff, even like the file hash, yes, you could get the file hash, but you don't see all that just by looking inside of the OneDrive folder, the Google Drive folder, the Dropbox folder. So having a lot of this other stuff is a little bit more factually sound. And then how often these paths and files are you examining or currently explaining for Google Drive, G Suite, or structure of organization, things of Google Drive change according to your experience? I think the question is relating to how often is the file path changed? For example, C users, Bob, Google Drive. Very rare. However, one thing I do see a lot of, and I probably should introduce in the lab, is that a lot more of these tools are ingesting, I'll call it, more locations. So OneDrive, I think by default, and a couple of the others. Now, if you're not careful and you do a standard click, click, click install, what it will do is it will it'll also try and do your documents, your pictures, and your desktop as well. So there may be other things that are inadvertently sucked up into these solutions, I'd say. So that's why it can show you other default things or other things that I don't want to say default, but other locations it's syncing as well. So that's where looking at these rooms more important, not necessarily the default location. Me personally, I normally don't use the default location because I hate when things are just thrown in my documents folder. But I think I'm probably the exception. Most of them are going to be the default location, but you would see other places like desktop documents, pictures, things like that are being synced. Where that's super useful is not necessarily this machine that we're looking at, but if this is the same account the user has on their personal computer, they may be syncing a lot more over there. So that's where we can get a lot more information. But we do need to be careful what's in scope for investigation, what your user acceptable use policies say, because if they're syncing with their home machine and now you're collecting, pictures of their home machine and stuff like that, it can get a little bit hairy. So that's where I would consult with the legal counsel, but I first want to see what's actually being synced on this machine. Okay, back to slides. And then we can all see if things are removed, although this doesn't seem like it gets modified very often. I've tried deleting things and it didn't update the database, so I don't know when that column is being triggered. It could be certain conditions. And then you get the MD5 file hash, which is super cool because now you don't have to now hash everything for a court case. It's already hashed for you. Okay, and here's an example of what that looks like in the database. You've got all those different columns, the file names, the modified dates, who owns it, doc type, stuff like that. So you can identify what the documents are, their file hash, if it's been changed. Those file hashes are super useful because you could see the file hash today, but then in some of the logs, you can also go back and see what the file hash was yesterday or the day before or 3 days ago and see if it's been modified since then. So for example, and we haven't really come to that in the labs yet, but did the resignation letter or some of the other things inside Bob's different share file or storage locations, did they change from time to time? When did they change? And so you can get some of that information. So the SyncDiagnostics.log, it's got awesome insight into user activity on personal accounts. You can ship that in. So what I did personally is I took this log, the sync log, because it's got a ton of information, and then I uploaded it to a free version of Sumo Logic. And in doing so, then I could parse things out. I could do log reduce. I could filter on key actions. You could always do it through Bash and try and do things like grepping and whatnot. But I thought it was pretty cool to just upload it within minutes to Sumo Logic in a free account, and I was able to parse the information I wanted. And so some of the things I looked for: action create, this is like a file or folder that's created; action delete, it's when an object like a folder or file is deleted; modified, so if they've updated a document, if they've renamed a document, if they've changed a folder or document, if they've moved it to a new location, if they've shared it, or there's a new owner of the document. All of those are kind of key things that you may want to parse for. And then within this, it also shows you where it happened from. So not just that it was renamed, but was it renamed locally, or was it renamed from the cloud? So did they log into OneDrive, or sorry, Google Drive.com or drive.google or whatever the URL is, and did they make the change there and then it got synced to the local machine, or where did the direction come from? So the direction action is important because it shows that. So download means it was changed on the cloud, and upload means it was changed locally first. Okay, a couple other things. In a name equal you semi-quote, and then you could have like an asterisk or a wildcard there and another semi-quote, and you could parse for all the file names within this log file. So pretty powerful to see this. So here's an example. It's messy, and this is why looking at a text editor, it's not super convenient, but having something like Sumo Logic where you could extract fields and use regex definitely helps a bit more. So this is where I use Sumo Logic, and I just did a log reduce, and you could see here that this action download, and then the direction download, so things that were pulled from the cloud locally, and then action with wildcards there, so different types of file actions there. On the far left side, there was 23 of those events. So this log reduce within Sumo Logic, not just promoting them, but it's just one that was easy for you to get set up, is that you can quickly see what type of logs you're looking at, and you can dive into those a little bit further if I would have clicked that 23 there. So whatever works for you, this just works for me. Snapshot.db, looking inside that cloud entry, we could see doc ID, file names, modified, ACLs, doc types, removed, checksum, shared. So this is everything that's on the cloud. And so I think this goes back to someone else's question. There's a few different, within the Snapshot.db and some of the other databases, these different tables will tell you what's on the cloud versus what's locally. So even if they opted not to sync it with their work machine, you still may be able to see through this cloud entry table documents that are in their cloud version that they didn't want synced locally. So that's super useful as well. So here we get the same kind of thing. And in this case, in your labs, I'll save you some time. I did not prevent things from being synced. Everything is just being synced, but this is where I would go to see if there was stuff in the cloud that was not local. And then we've got between the Snapshot DB and Cloud Graph DB, we can also see where things are. So it does get a little bit confusing. You're gonna have to map stuff because they've got child doc ID and parent doc ID, and it's got that unique document ID. And we can see that they're the first, not the first one, but rows 2, 3, 4, 5, I think up to 5 are within a folder. But we don't know if we look at that parent doc ID column, 1NGR, 1NV. I don't know what that is, so I need to now go to a different table to map that back. Kind of like that obfuscation string text file, we need to now go map that back. So if we look at the Snapshot DB's cloud entry and the cloud relations table, we can then there map that, and we can see, oh, 1NGR, 1NV, blah, blah, blah. That's actually the finance folder, and the file that's sitting within there is the we can't see the full file name, but it's called something, the Mike Wylie, and we can figure out what type of doc type it is. So you might have to toggle between the two different tables to kind of figure out the file names there. Okay, so I'm going to do a quick walkthrough of the lab, and then we can, I guess, take a break and do some of that on your own. So let me pull up the next lab document. I'll do a bit of a quicker walkthrough. Okay, we're doing Google Drive.
And if anyone having any issues to get to the docs from GitHub, please let us know.
And so as I get my lab machine up, this is the lab file that you're going to take a look at and that I'll be referencing. And let me just close out the stuff from our last lab so I don't confuse people. Okay, and now I'm going to switch over to my VM, just so I have a clean screen. So if it didn't, I've noticed that the database browser sometimes does not get put on your desktop. And so what you might want to do is go into C program files, and you'll find it here. DB browser for SQLite. And then you can click on DB browser for SQLite executable. I've also mapped it down here on my taskbar. I just noticed that on a couple of my machines. I think I unchecked maybe like the button that made it on my taskbar there. But this is basically the SQLite viewer that we're going to take a look at. And so the instructions, let me get down to my detailed walkthrough. Okay, so I tell you to go to the SyncConfig database. So I can either go File, Open, or I can click this button here that says Open Database. And I'm going to go to my evidence folder, which is in Downloads, Demos, Evidence Desktop, C Drive, Users, Bob, App Data, Local, and then we're talking about Google Drive and User Defaults. And then what's the first one? I want SyncConfig. So I've got that here, syncconfig.db. I'm going to open that up. And then it's going to do the database structure. But what I want you to do is click on this Browse tab just to the left of that. And that will then, essentially, it's the same thing as I would have double clicked on this data table, but it lets me have more of a spreadsheet type view of the database. And so I can spread this out a little bit more. Okay, and so some of the things I'm going to have you look at is, for example, the app highest version. So we could see this 3.49.9800 is the version that I'm using. We could see if that's the latest or not. And then what else do I want you to take a look at? The local sync root path. So scroll down. I think I missed it. There it is, local sync root path. And then in the data, we can see, okay, Bob, Google Drive, that's where it's located. And then let's go over to user email. We could see that they're using the same email address as the last example, bob.mclee.re@gmail.com. Okay, let me go down to the next question. What's the file type? Oh, I see. So we're opening now the Cloud Graph database. So I'm going to click on Open again and go into Cloud Graph. Okay, and we can see here by default in the Browse Data tab is that I'm using the change stamp table, which really doesn't have a whole lot. So if I click on this up here, this table drop down, that lets me look at some of the other tables. And in the question, I ask you to look at the Cloud Graph entry. Okay, and now we can see here that there's some, the question is, so what's the file name for doc type equals 6? So if I look at doc type here and I scroll down, this is the 15.1.1.1.6. Down here I have something with a doc type 6, which 2 through 13 are Google Doc formatted. So this is a native Google Doc item. And what's the file name? So if we go over here to file name, we could see, well, what is that? Ways to tell your boss you're leaving. That doesn't sound good. Okay, and then if I scroll down, look at the modified date. Okay, so then let's scroll to the left here, to the right. I think that was actually closer. Oh, modified was right there. I skipped it. Again, it's epoch time, Unix epoch. So if I click on this, copy, you could go back to the website I give you and find out the exact time and date in GMT, then subtract 7. Okay, someone asked about doc type. Can I repeat what that is? So the doc type, if we look at the, in this case, Google Drive is telling us the file extension, but we don't actually know specifically what this is. So it's telling us that it's storing what type of document it is. So for example here, ways to tell your boss you're leaving, there's no file extension for this one. So in that case, I go to doc type and it's 6. And so back on the slides, I don't want to pull it up in a minute just for time, but I showed a different graph that said what some of those were. So like one was a native file, like a text file or a PDF. 2 through 13 were Google Drive. So if you create like a Google spreadsheet, not an Excel file, but a Google spreadsheet, I think it's 2 or 4 or something like that. I think 6 is a presentation, a Google presentation. So it's telling us the format or what type of document this is. So it was created in Google Drive, and it's I think, presentation or something like that. It doesn't make sense for the title, but we can go back and look at that. Okay, and then so we get the modified time there. Let me go and see what else it wants. Okay, so the other thing here was we wanted to take a look at this doc type. So we can see that this doc ID starts with 1YW and ends in 20 or 20. And so my next question is further examination of the file name database uncovers additional documents of interest. doc ID 1MP. So I want you to take a look at the one that starts with 1MP. So this one here. So this one says resignation letter ready, and there's a timestamp here. So I'm saying basically keep an ID and keep reference to this doc ID here. So you might want to copy it, and then check out the timestamp. So you're going to convert this to epoch time and figure from epoch time to GMT and then local Los Angeles time, and figure out when this document was last modified. And then this doc ID part is going to be useful for other areas if we want to see, well, this is just a list of documents, but was it in the root or was it in the finance or the operations folder? Where were these things located? So what we'd have to do is we'd have to take these doc IDs and reference the cloud relations, and this is going to tell us where everything's located. So in this case, everything that we have here that's on the cloud was just in the parent, but if we had a bunch of other folders like I had in the slides, this is where we would see basically the structure, and we could map out the file structure of the cloud and local and et cetera, et cetera, et cetera. So the other piece I want to pull up is I'm trying to rush through this so we can all actually go through the lab, is we want to look at the SyncDiagnostics.log. So I'm going to go back to Windows Explorer. I'm going to go to my evidence. App data, local, Google Drive, user defaults, and then synclog.log, right click, and Notepad++. Okay, and we can see there's a lot of information in here. There's over 7,000 lines. Again, this is where I would use something like a SIM, but what I'm telling you to do is look for things, keywords. So you're basically going to go up here and do search, find, and we can look for keywords here. So it says look for resignation letter. So I'm going to copy this, paste it in here. And so one thing you do is you could do find, and do next. Or the other cool thing you could do here with Notepad++ is click find all in current documents. So if I click that, it actually gives us at the bottom of the screen all instances here where that appears. And so in that case is where did the file originate from? So we have to look for the create action, and we have to look for a direction. So if I start parsing down here, I can start looking for different things, and I'm probably not going to identify it right away, so you're going to have to spend a little time looking through this. But if we look at, here we go, like action create, this is what you're looking for. And then if this was the right one, direction upload. So you're looking for file name, keep going, resignation letter draft. So it looks like I actually just luckily found it right at the top here, direction upload. So it stemmed from the local file system and it was uploaded, synced to the cloud, and the action create there. So this file was created, the resignation letter, and then it was synced up to the cloud. So it didn't start on the cloud or another computer. It started on this local file system. They used a work computer to write the resignation letter. And then we could look at the timestamp here. This happened on the 16th at 10:35, I believe that is, at night. And then if you keep looking down and some of the other stuff, we want to see if it's changed or other actions have taken, but you could kind of parse through these logs here, and it took it from 7,000 items to probably about 39 items. And you could see, look at this, all of a sudden up here, it's called resignation letter draft. And then down here, it's called resignation letter ready. And we can see that when it's ready, I don't know if this is the exact change. We'd have to go one by one and look at that. When did this happen? So on the 17th-ish, around 6 in the morning, it got shifted to ready. So something between 10:30, 11-ish at night on the 16th to the 17th here, something's happened and that was modified. So we can dive into that a little bit deeper, sorry, that's the word I'm looking for, in our investigation. Let me look at something else. Okay, and then we're going into, just for the sake of time, I'm going to let you kind of do the walkthroughs there. We're going to go through the Snapshot DB again, we're going to look, rather than the cloud entries, we're going to look at the local entries and look for a file called office lease, and we're going to see where the parent is. So just real quick, since I have this one up here, I'll pull this up and just fly through it. Snapshot DB, and then we've got a lot of different tables here. So the one I want you to take a look at is local entry. And the one thing I did want to point out here is that inode, if I could say it right, this is kind of like a global unique identifier. And so this is what you're going to need to do for the rest of the lab, is find your file names here. So for example, if we were looking at the README, you'd want to document this inode. And in that case, then you'd look through some of these other tables like, let's see, relations, if they have it. You can see parent inode, and this is how you're going to figure out where things are structured on the local file system. So I'm going to, there's only one or two more steps after that I didn't walk through, but it's basically the same stuff. We are going to give everyone a break here and give you a little bit of time to do the labs. And so, Victor, what time do you want to come back from the break and the labs?
Yeah, so if you guys want to do it right now, let's do a 5-minute break. We'll come back to 2:25-ish, if that's okay.
Yeah, sounds good. So we'll come back at 2:25 from break and/or labs, and then we'll give them a few more minutes to do labs, and then move on to the next part.
Yeah.
Okay.
Ready, we can begin the next step. Yeah.
Sounds good. Okay, I'll be around if anyone has questions. Otherwise, enjoy your water break. Okay, so Mary, about the when to use the child doc ID and parent ID, it's really, again, just a different way of showing where to find some of the information. I would say probably the only time, if I didn't have access to the logs, that I'd be more interested in the table might be for the cloud only items that might not be showing up in the logs. So I might want to look into the databases for the cloud entries and see what's there that did not get synced. And if it didn't get synced, it's probably not going to be in the logs. So that's probably the only reason I would look there. I'm kind of showing you just different ways and different pieces. So maybe the logs weren't there, or they got rolled over and you don't have access to those for whatever reason. There's just different ways to find some of the information. Most of the time, I think the logs do show a full path of where they're at. So you wouldn't need to know the parent-child relationship. But in a case where it just says like file create that you found in the logs, but you don't know where it was created within the directory structure, that's where you could go back to the database and see where it's synced up. Okay, and then so the former question for clarification was in the sync log database. So let me go back to that. I'm trying to see the where that's coming up. Oh, selective slink value 0 here. So I think this is what this is referencing. So there's, from what I've been able to scour the internet for, there's no documentation really on this stuff. This is a little bit of, I don't really want to call this reverse engineering, but it kind of is, since there's not a lot of detailed documentation on this. So some of this is testing and some of this is basically guessing. So for example, like I didn't do a whole lot of research or due diligence on this key here of the user email. I'm pretty confident that's just the account that's associated with it, right? So some of these things were more interesting to me, and I actually did some due diligence and tested on multiple accounts to see what triggered these events. This is something I didn't do as far as selective sync. My guess would be that this is saying that no, I didn't tell it certain folders I don't want to sync. So it's basically skipping some type of check, but that's a complete guess. If this was a 1, that might have been where I've right-clicked and say don't sync this folder or something like that, and so then it does some other type of action based off of that. But again, that is a complete guess.
Thank you, Mike. And also, like, can you determine like if a user has like logged in and logged off multiple times on a system?
So a lot of those there's better places to find that. Most of the log files do show where there's sync failures. And so I noticed a lot of those, for example, when I disabled the network connection on my lab machine because I got tired of the programs updating. And then I looked in the log files and there was actually some interesting stuff happening. So for example, Dropbox, I think it does a different URL that's not associated with Dropbox.com. It was something like api.dropbox.net or different URL, and then /ping. And it was doing, I believe, a Python script in the background that was constantly checking, and it was identifying when it was failing to have network connectivity. That's how it was checking. So a lot of the log files are more of a place where you'd look at to see when it re-authenticated, and they have different ways of doing that, when it had network connectivity, when it did a re-established a connection with a cloud checker tool or whatever. So they all were slightly different, but a lot of times in these log files, you can see things here like aggregator.py. Let me see if I go down here and see something else. HTTP.py. You can see a bunch of other things here that are going on. I haven't dug into tons of here. On-off successful 8 sync client. So you could look at some of that stuff to make some determinations about the activity of the actual application. And then Box itself has a separate log file called box_UI. I think there's somewhere in the slides with the exact name, and then a number and the date. And that one gives more specific to the application, like sign in successful, auth verified, program closed. So it's specific to the application, not necessarily user activity. So they separate those out, but most of the other ones, it's all in one log file.
Alrighty, we're 3 minutes.
I have one question. Can I ask this?
Yeah, go ahead.
Yeah. So, is there any particular way using which we can determine whether this particular account is synced with other devices as well?
Yes, and so on some of those, most of the time it's in the databases is where you'll see that, and sometimes in the config files you'll see a device count. It's probably something I should update because that is some interesting information. In the first lab, I had 2 machines syncing back and forth, and then but then I had some issues with how that information was being reported, and I couldn't do certain things right. So now I went back to 1 machine and new accounts just to show simple demos. But there are certain fields that I've seen both in different databases as well as log files, as well as like the .ini file from OneDrive that show device count. And then you can also see device IDs in some of the databases. So it shows which device made that change. And some of that's super interesting too with, but it's a little bit more complex than we had in 3 hours. As you can see, I'm really far behind on where I wanted to be. And if I would have had more devices in a more complex scenario, it would have been even further. But yeah, definitely, I think if it was like an 8-hour class, I would have a second machine, and then you'd have to see, oh no, they didn't make any changes on their work machine, but then in the middle of the night, they were working on changes in their home machine, and it synced over to the work machine in the middle of the night. Or they had other documents they didn't realize that were their home machine that got synced over. So those are definitely things that are really interesting in an investigation, but it's tough to stage those things. And so I'd have to kind of have that worked out a little bit better. But you could definitely see those things, like I mentioned, the databases, sometimes the logs, and then in some of the config files, they'll also show how many devices or device IDs.
Awesome. And we will plan for that 8 hours, 16 hours, 24 hours. Hey, man.
Oh, man, I need more times in the day.
All right. Should we pick up the last?
Yep.
Lab?
Yeah, I think so.
Cool.
So normally I'd like to give more time, but I think for the sake, since we have 30 minutes left and there's another lab, I'll get through some of these here. So back to where are my slides? There they are. Too many windows and too many screens. So let's talk about Dropbox. This is one that I was super disappointed with in my research. Actually, I guess part of me was disappointed. Part of me was actually really proud of Dropbox. So they've since, I I think it was like 2011ish, they've been using encryption. So Dropbox uses encrypted SQLite databases. They are SQLite, but they're using SQLite encryption extension, SSE, and they're taking those keys and they're putting it in the registry. So I'm able to find the registry keys that they're using, where those encryption keys are. However, those registry keys are then protected by Windows Data Protection API, or DPAPI. There's a lot of research that was done by a couple different people that I'll reference here in another slide that they did a lot of research on it. They even built a kit. So Francisco did a deck WinBP or BX, sorry, toolkit that you could get on GitHub, and it's supposed to extract the keys for the Dropbox databases. However, I tried both the Python and I tried the PowerShell one, which the PowerShell script's supposed to be better since it's not dependent on a couple of libraries. None of them worked. I tried multiple different lab machines. Granted, I am not the best scripter or programmer, so maybe there's something I missed, but upon testing, I wasn't able to replicate that where I was able to extract those keys unencrypted and do that. However, I was interested in it. We may be able to do memory forensics, for example, volatility, or some other type of memory dump tool. And I was even wondering for future research if in Task Manager you can go in there, right click on a process like Dropbox, and you can then dump that process, anything from memory, into a dump file. I didn't have time to go into that and then see if I could find keys there or in another process, but there's a lot of other research that's done by Sands, Francisco, and a couple other people I'll mention in a second here and gave credit to in the first slide, where they were successful in doing this and getting those decryption keys and getting into the databases. But for my testing in the limited time I had, I was not able to get into those. However, there is a Dropbox.cache file that contains some temporary items. So even if you can't get into the databases, you can get into some of the cache files and carve out some things that are cached locally. And then also, if a user deletes things on their anything, if it's in the local file system or in the cloud, it's going to be synced to the local recycle bin. So you could just go into the Windows recycle bin and recover things if they thought they were being sneaky and deleting those. Obviously, if they press Shift Delete, that's going to be a little bit different, and you won't be able to recover that. It will be an unallocated space, which then, if it's more recent, you can carve out stuff from unallocated space. But we can go down a rabbit hole that's far outside the scope of this class. So I digress. There's a lot of logging that can be done on the enterprise versions as well. So here's the slide. If you want more information, there's a talk that was done for, what was the conference there? I think it's up at the top. It was at hack.lu. And the gentleman is in Italy, and he did actually, those two guys, I think, gave a conference talk in Prague, but the other gentleman, Francisco, who made the GitHub toolkit there that I've got referenced in the link that decrypts the databases, he references their talks a lot, and a lot of the information there about how to extract stuff out of memory, essentially. So this kind of gives you a breakdown here of, I was able to find the keys. It's an HKey, current user, software, Dropbox, KS, and KS1, and then it's in the client key, and you will find two different keys there. One of them's for the instance DB, and the other one's for instance 1. But through my testing with his script, other ways, I didn't spend a ton of time on it, but I was not successful in getting those decryption keys. And when I tried to even open the unencrypted, or what I thought were unencrypted databases, I kept getting errors with the database browser that we have in this workshop. So I did try those two different scripts he has, and also in Python, and I was not successful with those. But if you are able to, you can follow his stuff on GitHub, or look at the reference in the top of this slide for the talk that they did in 2012, where they talk about some of this stuff. Oops, I think I went way too far back. There we are. And so here's just a couple of different pieces. I'm not going to touch too much on this, but some of the stuff is not fully encrypted. The databases within Dropbox is stored there in the app data local directory. It's actually base64 encoded, but the ones that were base64 encoded, I couldn't find a lot of information that was useful. For example, when I decoded the base64, it was just the path where they store files, but that was kind of obvious from looking at the user profile and Sync Dropbox. So not a ton of value of the ones that were not encrypted that I found there. The most interesting thing is there is an info.json, and that gives you the file store location, the host ID, the team settings, if there is a team, a subscription type, free, paid, etc. But that's pretty much all I was able to extract there. There's a lot of research, as I mentioned, that's done before, and you could read more into that. Or SANS does some stuff as well on this, but I was not successful. So let's take a look at Box. Box has actually a ton of interesting stuff in there. This is probably one of the more fun ones I had to investigate. OneDrive was pretty interesting too, but Box has a lot of cool stuff, and their logging was done well. They separated things out, like the user interface, the application from the actual user activity, so that it wasn't all combined in one log file. So you can come back to these. I'll kind of touch on each one that's kind of important so we can get to the lab a little bit quicker. So the box stream, and then there's a number, and I believe that's at a certain file size where it then rolls into another log file. So you will see like box stream 0, box stream 1, box stream 2, and some of them will have the same date, some of them will be different dates. So again, my theory is that once it hits a certain file size, it just creates a new log file. And so within that, we can find things like the cache path. So that's super interesting that we see that the local or the app data local box cache, that's where we can possibly find cached files. And we're going to actually carve a file out of the lab. It gives it a weird file name and it doesn't give an extension, but we can do some other things for reverse engineering to figure out what type of file it is and then actually open those up. And that's what you'll do in the lab. We can see the anything that's dirty data, for example, things that two people are editing at the same time or it wasn't able to sync, it'll throw it in a directory there. We might be able to find something there. I couldn't trigger anything to get into the unsynced files directory, so I don't know what I would have to do or how bad I'd have to mess with it for a file to get stuck there. We can see the database path, log path, mount path, all kinds of useful stuff there in the start of the first box streams file. Log file, and then we could see other things that you can use sumo logic or grep or however you want to parse this out, but different keywords for you in the lab to take a look at: add file, add folder, on delete folder, on open file, on close file, on read file. And it's not just that someone opened a file, it was actually a ton of information. Like you can see what program or process was used to access the file. So I was able to see, for example, oh, a user used Microsoft Edge to read this PDF file. So it was really detailed logging that I appreciated as an investigator. And you could see there too, not just the file name, like add file 2020 strategic plan RTF in the bottom part of the screen there, but you could see it's an actual file. You could see that the inode ID, so we could see the ID of that, the parent, the size of the file, and sometimes you even got to check some. In this case, I didn't, but you'll actually see like an MD5 hash come across in the log file, so really useful information. Below that, we see add folder, and there's a finance directory that was added. We got the date, the time, and what I believe is that there's in the far, or I guess the start of each log entry there, we see the info in brackets. I saw another entry somewhere in the config files that logging was set to info. I have not messed with that to see if I can modify that to change that to like verbose or other words or things like that to get more detailed logging, but the info logging was very detailed there. And then, so if we look at the cache, this is something that's super cool because if you look at the cache directory, you'll see a bunch of files with unique IDs there, like 6D, 8 Foxtrot, 9 Alpha, 82 dash something else, but we don't see it's the type is file. We don't know what that is, so we can try and open it in a text editor. But my recommendation is a hex editor, and you can look at the magic byte there, and you'll do that in the lab. In this case, we can see it's an RTF file. If we could not make out, if it wasn't clear text, like it was a docx or an Excel sheet or something like that, or we can't just look at it in a text file, look at the magic byte, and that tells you what file extension to make this file, and then you can open it up in the respective program like Excel or WordPad or something like that. So we can carve out these cached files. And what triggers these cached files is that if the user syncs everything with Box, it doesn't immediately download the full file. But if the user accesses the file, like double clicks on it and opens it in WordPad, that's where it triggers this cache. I don't know how long it stays in this cache directory for. I didn't have enough time to just wait and sit and see if it got flushed out. But every time I opened a file, it got this random, or I don't want to say random, but this unique ID file got entered into the cache here, and I was able to carve this out. So if you don't have access to a file or it was deleted, you may still have access to the full file here in the cache. Okay, so we got the box UI. This is going to be a little bit more. This log is, as I mentioned, about the application here. So we can see box driver installed. We can see failed to connect to the internet. We could see login events, things like that about the application, not necessarily. And at the top there, we could see status logged out. So stuff like that with a timestamp may help you as far as user action outside of specific files, but how they're using the application or when they had network connectivity and whatnot. If we look at the box dash and then what looks like the application number .log, that'll give us other information here like content created, file names, other stuff, kind of like we saw with the other box log. I don't necessarily know why they've got certain things in here versus the other logs, so I would take a look at both of those. The different databases, they're going to be in app data, local, box data. I feel like this was something that I would have done with the naming directories that Box use, like box when I extract something from a zip and it's got another version of that name. So not sure why they've got box, but it's that's where you're going to find all your stuff. And within data, those are the databases there. The most interesting ones are going to be the metrics DB and the streams fs.db and sync.db. So within the SyncDB, if we look at the box item table, we'll find things like a unique ID for the box ID or the item, the object, the file or folder. We'll see if it's the item type will tell us if it's a file or folder. We'll see what parent item it was. So if we look back at the box ID of the directory, like finances or operations or personal or whatever, we can map that and find the directory structure. The file name, the owner, so which box account owns the file, if it was shared or not. It gives us the checksum. So this is awesome. I think I misspoke and said it was the MD5 hash, but the SHA-1 hash. So it tells us in the database the actual hash of that version. So if we get that artifact from the cache or from somewhere else, we can compare that and see if that's the same file that they have in their box account. And then you get the content created, updated, modified, etc., deleted, different timestamps that are obviously in Unix epoch time. So here's a nice database. It's actually a huge, I couldn't even get all the columns in my picture here because it just kept going and going and going to the right. So a lot of useful information here for you to see. And then you've got another within the SyncDB, you have the local items. So these are things that are stored locally, not just in the cloud, but local if they're not meant to sync or they are not syncing. You'll see these items in this table. Okay, here's an example of it. And then again, we have that inode. So that inode ID will help you trace things down in other tables or other databases. That seems to be globally a unique identifier within Box. Okay, the streams FS will find things like a touch sequence. I couldn't find documentation or really figure out what that was for. But it did seem kind of interesting, and I'm trying to figure out what that was used for or what triggers it. We'll see the date that things were cached. That's interesting because we can see that essentially tells us, I don't know how sound that would be in a court case, but it does tell us when basically someone clicked on it because that's the time it goes into the cache directory. We get the inode ID, which is the universal ID for that object, and the age, so how long or when the file was cached or if it's cached. Okay, and then this is kind of what it looks like here. So for example, in that column that says age, anything at 0 means it's not cached, aka on this local system, the user has not double clicked on it and opened it up. If we see a number there that starts in 15 and 8, that basically means, and it's Unix epoch time, and that tells us that it has been cached at some point in time. So we can convert that using the online converter and see when that item was cached. In this cache files table, though, we see the cache data ID, but we don't actually see the file name. So we could either map that back using the cache data ID or the inode ID into other tables, and that's for those, like the inode ID comes in handy. So we take that inode ID of 13, we open up then the sync database and we look at the local items table, and we can then map that inode ID and see that, oh, it's a business plan was the name of the file. So in the cache if I go back here, in the cache directory, we should see this thing that starts with A1B4, but we don't really know what file type it is or what it was called originally. So going through this step and mapping it back, we can see what that file name actually was originally. So then if we go into the app data local box cache directory and we open up that file that matches, see the cache ID matches there, we now know that was the business plan, right? So if we go back here, that's the business plan document. So we know the original title. And if we open it in a hex editor, we'll see that the magic byte there is PK or 54B0304, which essentially is a docx or Excel file. So we can rename that item to docx, then open it up in WordPad or Word, and we can see the actual document that the user had within their Box account that they opened up. So this was the cached version, even if they've deleted the item in their actual Box folder. Okay, in the Stream FS database, there's the FS node table. This is tons of information here. You could see, again, it's one of those that I had to scroll and I couldn't even fit everything on the screen. Everything from it's a file or directory, the parent directory, permissions on the file name, when the file was created, modified, accessed, the inode ID. It just kept going and going and going. So tons of useful information in this table. One thing I do want to mention about the created time, modified, and access time, I would not use these in a forensic investigation unless you were really confident on this, because it can give you some insight. But when a file is copied from a local file system to OneDrive, not OneDrive, but any cloud file storage solutions, it really differs from system to system on which ones inherit or preserve these timestamps. And so one thing that I know for Box for a fact does preserve from my testing is that the modified time. So the modified time stays the same from the original one. However, in the lab, you're going to see something that's kind of weird. You're going to see the created time, like let's say it's 6 p.m., but the modified time was 5:30 p.m. You say, wait a second, how was it modified before it was created? And that's because it's the modified time is actually inherited from the copy location. So it goes again outside the scope of this course, but going back to like NTFS forensics, is that the modified time actually it's proof that it's copied and not necessarily the actual modified time. So I don't want to go too much detail. It's a little bit confusing, but I just want to say that you can start getting some insights into looking into those different access, created, modified, but don't go take that information and say, look, this is fact. They modified this at this date and time, because someone's going to come back to you and say, well, then why was it created after it was modified? And they're going to kind of poke holes into your the facts that you're trying to prove. Okay, so Victor, what are your thoughts on if I just go out through the last few slides and then we can end on a lab rather than doing a lab in the middle here?
Yep, I think that sounds good. In that way, people don't want to hang out with us. That's totally fine as well. I understand.
Okay, and I can stay a few extra minutes and do the demo in the lab, but this way we can just get through the rest of it. So sorry for the time crunch here. First time doing this workshop, so we didn't know exactly how the time was going to play out here. So Citrix share-file, I did not put this in your lab environment. I apologize, but I felt like it was originally going to be part of the lab. And then as I dug into it, they don't even let you download the Citrix share file without having a trial or talking to a salesperson. I don't want to say it's talking to a salesperson, but filling out a form for a trial and your use case and stuff like that. So I feel like it's probably less prevalent that you're going to find a personal Citrix share file account because you do have to have a company email address and stuff like that. It did accept my Gmail account and a fake company name of research123 kind of thing. But it's still a bit of a wall to get behind, even just to download the application. So I thought most people aren't going to do that. Maybe they would do the trial, but they're not going to pay for it. So just a little bit of info about it. It's not in your lab. As I mentioned, the application, you have to start a trial just to even download the program. It's designed mostly for business and enterprise. There's no free version. And then what happens is it's similar to Google Drive for Business, where it actually creates a virtual volume and then it mounts an S drive. So it looks like a network share. The databases are unencrypted and they're SQLite. So it's similar to Box and similar to Google Drive. Some of the paths that I mapped out here for you, the different default stores, the database they have two different databases. One's for the local files, one's for the remote files or the cloud files. So you can see files that are not synced locally, which is super helpful. And then they have a directory there for logs. The most interesting log came out of Citric files underscore and then a date assigned to that. And that one had a lot of information. There was also a cache directory, and that you could carve out files. And I was able to, once I double clicked on some things, I was able to carve out some files similar to what we saw with Box. So a bunch of different databases, but the ones I had in the last slide are the most relevant. So that remote database, we see things like the directory entry ID. So it's a folder ID that's assigned, that's the parent of that object. We see the parent folder ID, we see a file name, and we actually get to see a global share file ID that's across all databases. So here's kind of what that would look like. I hear the baby waking up there. And then we see the remote database. We see other things like database item ID, the parent directory, item type. So we get a little bit more information, create date, and then we also get a hash. So things that are not stored locally but are in the cloud, it actually keeps a hash for that, probably for file integrity, but we can use that for forensics. And there's a ton of other fields. So similar to Box, I couldn't even scroll all the way to the right. There was just tons of information and things that I need to do more research on, like DB zone ID. I think that's to do with different instances they spin up, but there was a lot of useful information in here. And then we've got the local item DB, similar to the remote one, but this shows us everything locally, and we get a little more information like change, last access, last write, modify. The one other interesting piece that was in there was the cloud URL. So there's a URL in here, and I'll move to the next slide. And it shows so I use research 601 as my instance. We could see the instance as a subdomain, and then sf-api.com, and then we see an item and that unique ID there. So I tried to visit those, but my browsers wouldn't accept that. So I would like to dig into that a little bit more to see whether those are authenticated or not, or you could just access that somehow without authenticating, what kind of checks they're doing. But you can actually see the path to all those items in the cloud instance. Okay, then we got a directory entry. This really just shows us the directory structure within ShareFile. And then the log file, there's some key things. If you're looking at this, you may want to parse out upload file, file system notifier, local, win, FSP, delete item, download, upload, read, callback. There's certain keywords there. These are all ones that I found useful for finding interesting files. However, I haven't mapped all of them. For example, the win FSP, there are certain things that were really useful and certain things that were not. So I've got to dive into a little bit deeper to figure out what triggers those specific events that we're looking for. But in a quick query, you can look for those things and pull out and extract some interesting events. If we look at the part cache directory, there's a read write and a read only directory. Don't exactly know what the difference is or why they're there, but most of the time I saw things in the read write directory for testing. And then we saw the Citrix share ID of the item, similar to what we saw in Box. And if they were named though, rather than that long ID, they were in a directory with the ID of the item, but then they were called 0.part, 1.part, 2.part. But same process. If you open it in a hex editor, you could examine that, look at the magic byte, modify it to docx there, and then open it up in a tool like WordPad or whatever opens that file type. So some final notes on this. As I mentioned before, the timestamps have not been fully tested and verified for integrity. Double check those, play with those if you want to use that for an investigation. There's just a lot of different events like a full move versus a copy versus a cloud copy, different scenarios I have to work through and just map out all the different actions and what accurately records the right time. So take those with a grain of salt and test that before claiming something as far as the timestamps. So some of the items like Google Drive, the shell or the on-demand files where it grabbed things once you clicked on it, there may be some issues as far as full disk encryption. So if you are interested in doing an image, and let's say you don't have access to the decryption keys, when you shut down the system and do a full disk image with something like FTK Imager, you may actually not get the full files. If you open up the file what you thought you had, you're going to see something like that shell where I showed you, where it's really the ID number of the document and stuff like that. So in order, if you really want all the files within Google Drive or share file and make sure that you have the actual files and not just the shell files, you may want to do a logical image, or use something like Cape with a triage image when the user's logged in to actually access the full file or trigger that parse point to download the full file. I just want to throw that out there in case you think that, you know, shutting off the machine, pulling the plug, and doing a full image, in some cases you may not get the full file. And then if you have the ability to look at the cloud files rather than just the endpoint data, you're going to get to your answers a lot quicker. But I'm assuming you don't have access to the user's Gmail account or their Google Drive account. So that's where I focused on this. And then in some scenarios, no application will be installed. So for example, they just go to drive.google.com or google.com/drive or onedrive.com, and they do upload download from there, and there's no application. In that scenario, we're not getting the databases or the log files like we would in the labs where I'm showing you. But I have identified some things. It's not great, but there's different actions within the different platforms that you can map to. And this is not an extensive list. It's just an example. For example, if you're looking at someone that's editing or viewing a spreadsheet, you can look at the browser history or the cookies or other browser forensics type tools, and you can see that they went to docs.google.com/spreadsheets. So if you can extract out some of the browser history stuff, you could get some idea of what they're doing or what sites they're going to and some actions. You could look at even the folder names. So you can go to, or you could see drive.google.com/drive/operations/finance in their browsing data, and you could see that they've visited those folders. You can't see what's in it or what they did, but you will see certain folders and certain indications of things. If they went to their trash, you could see that. Other things like Box, you could see that they went to app.box.com/folder, and then 0 is their root, or other, you'll see other folder names there. With OneDrive, you can actually see their CID, and you could see the directory they're in, like the ID of root. So that might give you some insight to the things that they're doing. Unfortunately, most of them will give like files, and they'll put obfuscated text, so we won't see the file names, but you can see the folders that they're viewing. And Google Drive, similar type of thing. You could see the folders that they're viewing as well. So real quick before we end here, I did want to show you how I extracted this data for your labs instead of using an entire VM. So what I did is I used a tool called Cape, built by Eric Zimmerman and Kroll, and I created one, and I'm happy to give this out to people if you reach out to me. I called it Cloud Storage Metadata.tcape, and what I did is I extracted things there that some of them are for other Cape files, some of them I built myself, but most of them are taken from a couple other, I think like SANS instructors or Eric Zimmerman. They had one for each specific file storage solution, but it was also extracting all the files, and I didn't want to do that. I wanted the metadata. So I stripped out some of that, and I added one for Citrix Sharefile, and I made it in one tcape file. And the reason I did that is because I didn't want to have to add in all the different ones for Dropbox and then Box and that and this and that, and have these different target files. What I want is one large file that you could push to a machine. And so if you check out my blog on themikewylie.com, I wrote one on how to do a triage image for using Carbon Black, but you could use any type of tool, even Active Directory. Let's say you have 1,200 systems and you want to go out there and grab all this metadata, not the actual files, because that might be owned by the individual, but you want all the metadata about this. You could push this tcape file and extract within 10 seconds per machine all the metadata for these top 5 different cloud platforms, and have that sent to an S3 bucket or an FTP server or locally on the machine. And you could start parsing through this to see if there's any DLP issues or data exfiltration or personal items on any of your endpoints within your environment. So I thought that would be useful rather than having multiple different versions or different target files. I made one that I could just push along with the Cape tool, and you could just basically script that through Active Directory or through Carbon Black Live Response or whatever tool you're using. So basically I use the Cape here. This is the GUI version, but at the bottom of the screen, you can see the command line version that you could script out and push through any type of scripting tool. Or SOAR if you have that in your environment. I picked the source as the C drive of Bob's machine. I dumped everything, and normally I wouldn't do this, but I dumped it in the downloads folder called Evidence 5 just as I was testing. I picked my cloud storage metadata tcape file. You could also, I had it go as just a regular folder, but you could easily make it a VHDX if you check that box there in the container, and that would make it a mountable drive, so you could just mount it onto a Windows machine. But I wanted to make it simple, as quick as possible, so I just made them flat files there for you. And then I tell it to execute, and we could see there in 11.9 seconds, I had different results. The first time I did it, it was like 8 seconds. Second time was 9, then 10, 12. So I don't know the variance on time, but you could see that I extracted all of that data for the 5 top cloud platforms on this machine in 11 or 12 seconds there. So it's very quick and scalable to do that triage acquisition in a real world environment. So I've got this here, but Victor, do we want to say anything in closing before I can do a demo? But I did want to respect people's time if they've only blocked it off till 3 p.m.
Yep. Yeah, if you go to the next slide, I'm gonna just confirm how. So again, this is a recording, and it will be a recorded session. You can watch it on my YouTube channel. All the slides will be posted on LinkedIn, Twitter. If any one of you guys wanna get in touch with us, have any questions regarding this session, have any suggestions, feedback, you can send it to contact@varsitystesting.com. There's a QR code if you guys wanna just use that to subscribe to our Twitter, LinkedIn, YouTube channel. Once again, Michael, thank you so much. This was really great. Thanks so much for doing this with us.
My pleasure. I appreciate you you having me here and letting me do this, and everyone who joined us on a Saturday. And I'm absolutely willing to do the demo here. And if anyone wants to stick around, that way they can walk. We could do a walkthrough.
Let's do it.
Okay. So again, thanks for everyone for joining us on a Saturday. If you've got to take off, appreciate it. Please connect. I'll go back on this slide. Connect with me on LinkedIn, Twitter, and like I mentioned, if you want that TCAPE file or anything else, or want to talk a little bit more deeper than a 3-hour conversation that we had here, but specifics, happy to do that too. So let me switch over to my VM so I could do the quick walkthrough. Okay, VM. And then again, just for everyone's reference there, we did not, I don't have a Dropbox lab just because I couldn't extract the keys and I couldn't find an easy way to do that if I couldn't do it. So the next lab is on Box here. So let me pull up my Box. Okay, so the first step I have is that we're gonna, in Notepad++, we're gonna open up the Box streams. So I'm gonna browse back here to my evidence, local data, box, and then it is within logs. We can see they nicely laid this out for us. So I'm going to go to box stream 0. So the very first log file, this should have the initial data that was synced up. Oops, let me open it up in Notepad++. Okay, and so then what I'm going to do here is I'm going to search for add file for that action. So these are one of the things I mentioned in the slides here. So add file, and again, you could search one by one find, but I find since I'm not using like Sumo Logic or Elasticstack or grep or anything, I'm just gonna do find all in current document. And that then brings up at the bottom of my screen all the instances where this happened. And luckily it's only 11 out of 578 events. And so I can parse through these one by one. I'm going to move a little bit further over to the right here so we can see these events. So add file, it's a file added to Dropbox. We could see that it's got the full directory. So the first file was a readme.txt. We could see in the finance directory, there's these files here. And then within the operations directory, we had a bunch of other stuff here. So this is the stuff that was probably shared by someone who was within the company prior to to Bob leaving the organization. So if we look at the date too, I wish this was further back in my staging, but we could see this was early on the 16th. This is the first events that happened. So he probably accepted the share of the operations and finance of whoever was the owner. Okay, then so the question there is that opening. Oh, then we have to open up, oh wait, I missed the first question there. So what's the first file added? So that's the readme.txt file. Then the next instruction is to open up the box stream 2. So this obviously, it's got so much data before here, it essentially times out or rolls into another log. So if I go to open, and I want you to then, I've parsed through all these. This was a very short time that it was running. It was just one night and one morning, but I want you to go to box stream 2.
And in box stream 2, what we're going to do is a find, and we're going to search for on create file. So now we're looking for just not a file added to the local local file system from the cloud, but I want to see when a file was created on the local file system. So again, I'm going to go to search, find. I'm going to paste in these brackets with on create file, and I want to find all and current document. There was only 4 hits for this. And I can see here, this is why I think Box is super cool. Not only does it give us that action of on create file, but look, it tells us that it was through Explorer. So I probably was in Windows Explorer and just right clicked and said create text file or create, you know, RTF file or whatever it was. So essentially I went here, right click, new, RTF. That's essentially what I did. So it's telling us it was done, what program or what process did that, which is really helpful in forensics. And we can see here that there's different files here that were created. So the question is, what 4 files were created and what was the time of each? So we've got the names of the 4 here. We've got a resignation letter draft. We have a business plan 1, draft client email, and then a temp file, which I'm not really concerned about. And then we here have the time. So these were on 4/16 at 22:35, 22:40. So the resignation letter and then business plan were done almost simultaneously within 5 minutes of each other, which is suspicious. And then the draft client email was done about 15, 17 minutes after that. So all these events happened very short after each other, which is concerning. Okay, and then we want in the same log file, prior question, we're going to scroll to the top and we're going to look for Microsoft Edge. So I'm kind of giving you these things. You'd obviously want to use a log parsing tool, but I'm going to go all the way to the top of this text file just so that it finds everything in order. And I'm going to do now look for the action of on open file. So I want to see when a file was accessed, not created. So I'm going to do Control F, paste in this on open file. And I'm going to do find all in current document. And we can see there's a lot more here. There's 198 hits, but I'm looking for something by Microsoft Edge. So I'm going to look down here in this area and see, okay, it was by Streams, Box, Google Drive Sync, WordPad. So we can see here that these items were created by WordPad or opened by WordPad, I apologize. And then we have some other stuff here like Microsoft Edge. And so we could see that this item in finance, the Mike Wylie 2015, 2019 balance sheet confidential was opened up. It's a PDF file. So it was opened up in Microsoft Edge to view the PDF file. So you can see not only when they opened the file, but what program they were using to open that as well, which is super cool. Okay, and then now I'm telling you to go to the cache files and let's see what we can find there. So I'm going to go back to Box, Cache, and then we've got 6 different cache files here. And so what I want you to do, I'll show you a first one here, but in the lab is you're going to right click on each of these and you can see it's just a file. It doesn't know what they are. They're cached items. I'm going to go to open with, and I'm going to do HXD hex editor. And here I can see that the magic byte, I give you a link in the labs to see what 25, 50, 44 is, but a lot of times you can even look in this ASCII area, the decoded text, and see that it's a PDF document. So normally here, if I'm just going to minimize this, if I try and double click on this, it says, I don't know how. I don't know, there's no file extension. I'm not Linux, I can't figure that out for you. So what we can do here is just rename it .pdf, since we know it's a PDF file, open it up, and we're now going to have access to what that user viewed. This is the cached version of it, which is identical to the real version. Okay, so you're going to go through these. I have a question about which one's an RTF file, what's some of the other ones, or what's the name of the file, and you're going to find some interesting, suspicious stuff in here. That's going to lead you to your conclusion whether or not Bob was acting poorly. Okay, and then so some of them are RTF files. You'll see other things in there. The ones that are a little bit tricky, I'll just give you a hint there. The ones that show us in the ASCII area here in the hex editor of PK, it's basically could either be a docx or an Excel XLSX file. So we don't really know which one it is. You just have to play with it. But if you get it wrong and you try and open it, it won't work. Especially those docx, it'll try and open it in WordPad, and if it's an Excel file that you've named .docx, it will say it's corrupt or it doesn't work right, so you can try again there.
Let's see. And then, so step 4 here, we're going to open a database. So I'm going to go back to open a new database, and we're going to go to app data local, box, and then data where the databases are stored, and then stream FS. And within that, okay, I want you to go to the cache file. So this is going to give us information on the cache files because we didn't know what the names were of those files, right? So if we go back here, it's the random names. We don't know what they are exactly. So we're going to go in here in the cache files, and we're going to look for the inode ID and the age. And so if we see age here, I can even sort by age. These are 1, 2, 3, 4, 5, 6 items that are cached, which happens to match our directory here. There's 6 items in this directory. So these are the items that are cached. And if we look at the age, and convert this from epoch to GMT, we can figure out when these items were opened. And obviously we could go back to those logs and verify that as well. But we want to kind of look at these items here. So if I want to see, well, what was this original PDF called here? It starts with 06F. So let me go back here and look for this item, 06F. So I think that's this one here. And I can see that the inode ID here is 7. Okay, and so then move down to my next step. Okay, and if we go into the tables here, so we just keep in mind inode ID was 7. But if we go here to the different tables and we go to FS nodes and we look for the column of inode IDs, okay, and I sort this 7 here, and now I can just follow this column, so this row is 5, and we can see that keep scrolling, now we can identify what the name was. Oops, just want to open this one. So if I copy this name, go back to my cache, this is what well, that didn't work well. Let me go back and copy that again. Just copying the whole line. Copy. This is what the original file name was of this item here. Okay, so it was the PDF version of that balance sheet there. That makes sense. Okay, so we can start mapping these out by file names, what type, and we can recover and carve out some of those files. So you're going to grab some information there about the created time, modified time, access time, the inode IDs, convert that kind of stuff. And then this is one thing I did want to show you here back on my screen about because I did see there's a question about these created timestamps. Are the timestamps when the file was first created on the machine or when it was first synced with box folder? So that's kind of where I want to go into. And let me show this spreadsheet. This is in the detailed walkthrough, so you already have this. On the left side here, you can see that this document, draft client email.docx, the location was in the user profile, and it's called documents. So this is where I created it. I drafted a document called draft client emails. .docx, and I put it in the documents folder, and the created time here was April 16th at 10:56 p.m. This is when I created the document on the actual file system. Now, what I did is I right-clicked on that document, I did copy, and I went over to Box and Dropbox and Google Drive, all the different platforms. I right-clicked again, and I pressed paste. Now that's very different than if I would have dragged it over or done a hard move. This is a copy. So when I copy anything in the NTFS file system, one of the behaviors that happens is that the created time gets pushed over into the modified time of the duplicate. Okay, so on the right side here, we've got the item that's in the Dropbox. So I right-clicked on the original copy, went over to Dropbox, pressed paste, and look at that. The created time from the original file gets pushed into the modified time on the duplicate one, right? And then now look at the created time here. This is where it gets confusing because the created time is later than the modified time. So that's where a lot of people get confused and say, this doesn't make any sense. How can you modify something before it's ever existed? No, that's the NTFS file system telling you that this is evidence of a copy, a file copy action. So that's all that I was saying as far as that is, and this is a whole conversation that we could probably spend 30 minutes on of actions of the NTFS file system. But that's the only thing that that we can determine right there. The access time, most forensic examinators say, is you can't rely on that stuff. And there's many cases where there's been a bunch of issues in court because someone said, oh, it was accessed this many times on this date, and it's not accurate because there's certain events that trigger it, and it doesn't always trigger it. So created time, you know, that we really, if we see this discrepancy in time, all we can really say is that this was the original created time in the modified field, and that the created time here is when it got copied over. But if there is sequential, like we have on the left-hand side here, where the created time is before or at the same time of the modified time, we can say, oh, this is an original or a move. So it's a bit of a, I often look at a grid because it's a little bit confusing to look at that. And then what else? So I want us to just go back over to my VM. Okay, and if that didn't make sense, don't worry. The first time I saw that, I thought to myself, what the heck is Microsoft doing? Why would they do something like that? But you start, I wouldn't say get used to it, but you start seeing it and you're like, okay, I know what's going on here.
After all these years, you still ask this question about Microsoft? Come on, man.
Yeah, and I still have to reference my grid because it's easy to get tripped up on when you see something like that. Okay, so and then there's also obviously different versions of Windows. So I should have thrown that caveat out of there, right? So I think Windows 7 and before, from memory, it did update access time, but then after that, they didn't update access time. So there's, like I said, there's a whole matrix you kind of have to look at to validate whether the times are accurate or what they mean based off of a bunch of conditions. So it's not straightforward at all. And then I wanted us to take a look at inside the log file, which one we want, log and the version number. So we're going to go back here to box, logs, and then log dash version number, which is going to be right here. Okay, so I'm going to open this up in Notepad++. All right, and then I'm going to looking for things here like is underscore deleted, and I'm going to look for all of them in the current document. We can see there's 32 hits for that. Can't believe I'm doing this in Notepad instead of grepping for this stuff, but it is what it is on Windows. And then we're going to look for things. The question is, what's more concerning is what happens between 6 and 6:30. What file names stand out to you for your investigation? What's the timestamps? So if you dig into some of these, I'm going to have to scroll a little bit here on some of these deleted items, and we can see some of the file names here. When you dig into some of these, where's the file name? Oh, here we go. Okay, so the name here, we have different names, right? So we've got ready, and then we have draft. And we have draft here, and it changes a couple times. So it kind of makes you look into that a little bit and see when the file name got changed. And then you can also look if it was modified. So there was something happening. If we go and look at the time around here, around 6:17ish to 6:26, the file names start changing. So you could start looking into that and see that there was deletes happening, modify changes and things around that time to the resignation letter. And that kind of ends that lab. When you look at some of those other cached items that are dug out there, if I go back here, there's some more interesting things about answering the question. And just for those of you maybe who don't want to go all the way into it, I think it's this one here. If I open it up with a hex editor. Okay, so we can see it's a PK is the magic byte. So I'm guessing it's a minimize this, a docx. If I open that one up, dear client, after 10 years, the Mike Wylie LLC, it comes to part ways. As a valued client and friend, I'd like to encourage you to leave the Mike Wylie LLC as well, and maybe treated better at my new firm where I'll be a co-founder. Please keep this between us, Bob McLee. So there's our final evidence that there was a file that was opened the morning of the resignation. There's a resignation letter that got changed from draft to ready. And then this file here shows that it was going to be sent out to clients in the morning of the 17th. And Bob McLee is definitely violating the non-solicit clause of his contract.
So we probably could have done that all in one cloud solution, but I tried to give you little pieces of evidence in each one so that you didn't have all the answers when we first did Microsoft OneDrive. You had to kind of get little pieces along the way to get used to the different applications, but I encourage you to get all the answers and build a timeline in each platform and get some experience with that. So that's going to end at least the demo there. I'm happy to stay around for a few more minutes, maybe till 3:30 if people have questions, but otherwise, that pretty much ends all the content I have there. Sorry for going a little bit over, but I wanted to make sure we had time to get through the content and do a final lab walkthrough.
Awesome. That was awesome. Yeah, and attendees, if you would like to, get involved with more open source tools and they want to learn more about it, we're going to have a session on Zeek/Pro. We're also setting up sessions for Sarikata, snort rules. So just stay connected with our social media platform to know about those sessions.
I'd definitely like to attend that. I love Bro Zeek.
There you go. We're going to talk about signatures. We're going to talk about protocol parsers, and we're also going to talk about how you can set up a home lab to just start playing around with it.
That's incredibly useful. Well, thank you guys for all the education, training, and putting on these events for everyone for free. It's we really all appreciate it.
Thank you, Michael. Thank you.
So I'll be around a few more minutes. If anyone has questions, feel free to connect on social media and with me, as well as virtually testing. And if you have questions in the labs for the next 10 minutes, otherwise I got to head out and play with the baby for a little bit.
Yeah, let's wait for 4 more minutes. Guys, if you have any questions, please go ahead, type it in Q&A. If not, again, you can reach out to us, send us an email or contact@SyncDiagnostics.log. I'm sure Michael will be happy to answer those questions eventually when he doesn't play with the baby and doesn't have his father hat on.
Yeah, gotta start with the next workshop. I think we're going to be doing one with Mary, who was in the chat today. We're doing a intro to Linux for cybersecurity professionals and looking at how you can utilize that to make an analyst job a little easier, which was also submitted to B-Sides Vegas and DEF CON. So I doubt those are going to happen this year with COVID-19, but maybe it'll be virtual, or maybe we'll do another one with another organization at some point.
For sure, for sure. All right. Everybody is disconnecting and saying thank you. So thank you all who have attended. So Alexander, if you missed anything, we will be posting all of this recorded on YouTube. And if you want to know our channel, it's right at the screen. Go ahead and scan that QR code, or you can take a screenshot of this slide on the screen.
As always, the best way to reach out to me too is LinkedIn. So if there's specific questions, you missed the content and want some more explanation on that, or you're going through the labs and something doesn't make sense, shooting me a LinkedIn message probably gets me pretty quickly to respond, and I can answer things in a little more detail.
Awesome. All right. I don't think so any more questions are coming up. Mike, let's get you time back to your baby.
Sounds good. He'll appreciate that. So thank you again for CSA for hosting it, virtually testing, and Victor for your time on Saturday, and let me go a little bit over. Thank you very much.
Thank you. Cheers. Take care.